need to get off YouTube. They are wrong about their entire channel's existence. My channel is not flat Earth only.
Yeah, got it. Jeran, 1 second. Welcome to the panel, Del. And how's it going today, man?
Oh yeah, how you doing?
Yeah, can you be a little bit? Can you turn your volume up just a tad? I think you're coming in a little bit soft for me, at least. Let me. I'll do it. I'll just make it a little bit louder.
I'll switch my camera off since nobody else.
Yeah. Go ahead. Go ahead, Del. I just need to take a 2-minute break, real quick. But go ahead. The floor is yours, Del.
Wait, you're gonna take? Oh, you mean you're gonna take a 2-minute break on your own? All right, I gotta pee when I get a chance to. Go ahead, Del.
No, wait. If you want to go for a pee, Jeranism, I'll wait.
Yeah, let me do that real quick. Let me just pee and I'll be right back. Yeah?
Cool.
All right.
So while I'm here myself, there seems to be a lot of focus on, visual interpretation. Things like the sun, people presupposing things like the sun and then making interpretations based on visible phenomena. And a lot of relevance is placed on these things when physics is being ignored. So, the question that I'm going to ask, and I'll ask Jeranism when he comes, and I suggest that everybody out there asks the same question. Can your model exist without physical downwards acceleration? The answer to that question is no. The globe Earth and stationary flat Earth both requires a physical downwards acceleration, which in reality does not exist. So this is where I get an issue when people have a focus, misdirected focus on the wrong things. The root of the globe Earth model, it's a requirement. Without a physical downwards acceleration, the globe Earth model is dead and done right from the off. Now, if you're a flat earther, if you're somebody who's looking to expose that model, then that's your silver bullet. The fact of the matter is that we have a vector in reality. Now, that vector you can test for yourself, and it's demonstrably up the way towards your feet. Demonstrable, repeatable by every single person alive. I'll just wait for people to return so that I can have the discussion.
I'm back. I'm back. I just got back. I'm here. We're waiting for Jeran to come back. I don't know if Rose is still here, but Rose, you can always chime in anytime that you feel you need to. Just fit in where you can fit in. But obviously, things got a little bit more serious with Del's presence. But how you doing, Del? You doing all right over there?
Yeah, I'm fine, mate. Getting on okay.
Yeah. All right, that's good. We're just having a conversation, and not that we all have to agree with everybody, but as long as we keep it civil, I think we could have an interesting conversation here.
Well, the thing for me, Natch, is people can have disagreements, but in regards to physics, for me, if we're going to apply reasoning and we're going to utilize things like physics, then everybody who's involved in the discussion, those that make claims are duty-bound to demonstrate through practical physics and justify the reasoning that they're assuming or the reasoning that they're standing upon. Now, as far as I've seen so far, none of these people can stand on any solid ground of reasoning in regards to their claims, especially with physical downwards acceleration. Electrostatics, people are saying in the chat, again, electrostatics is a factor in our reality, but it is not responsible for the vector that we experience. If people are going to claim that the gradient of pressure that we have, buoyancy and density that we have, people now are going to have to utilize electrostatics in order to demonstrate how that's possible. Now, so far, there's been absolutely nothing other than wishful thinking and, sophistry being applied, the very same as the globe Earth, because the stationary Earth model and the globe Earth model are one and the same. They have both a commonality of physical downwards acceleration. They both require it. Now, again, anybody that's listening to this can go and test for himself today that there is no physical downwards acceleration. So, people are talking about all other manner of aspects of this topic, but ignoring this very fundamental, massive component, which bothers me.
Yep. Jeran, are you back with us? Okay, apparently not. I agree. I mean, like when I looked into it, I questioned why there is no so-called buoyancy when things are at free fall, and why should it matter if gravity, so-called gravity, is there, and there is a kind of a downward vector rather than upward vector of things. Things are being pulled to the ground rather than the ground meeting up. Then it shouldn't matter. Like when you look at the slinky, like my assessment of that situation would be like they should all moving down while contracting together. But that's just the way I would look at it.
Well, it's actually wrong, Natch, because if you're a globe earther or a stationary earther, you've heard them both claiming that when I showed an accelerometer and saying there's no displacement from the accelerometer, that's showing that there's no acceleration, they all now say that that's because everything's accelerating at the same rate, which is a claim of a force and, the act of a force, which is totally preposterous to reality. Now, when we show the slinky and the ping pong ball in the jar dropping, that slinky is now elongated due to the buoyant effect of the ping pong ball. Now, according to these people, at that moment, everything now should accelerate towards the Earth at the same rate. But as we let that go, the spring inside contracts under its own tension. So there's another contradiction to that claim.
Yeah, I mean, you know me, I'm in agreement with that line of thinking. But again, being a retard of the flat Earth community, it might be incurious, But really, all jokes aside, I do think these are very healthy conversations to be had with people who have varying beliefs. Because, like, if we are really honest with ourselves about, hey, what is this thing that we call gravity? What is this stuff we call celestial, phenomenon and such, and then let's put all the data together, and then let's really try to figure it out the best that we can, and I'm not an expert in any field, but I do question reality, and why people think the way they do.
I'm back. Sorry.
Yeah, go ahead. So, Jeran, if you don't mind, I'm going to give the floor to Del, and then you are welcome to respond. And I'm going to give it, give everybody the same opportunity, right? So, right now, I'm not making a hard amount of time that people are speaking, but I will start squeezing myself in if I feel like the conversation is becoming redundant or people are repeating themselves.
Okay.
Go ahead, Del.
Jeran. Can the globe Earth model exist without downwards acceleration?
Can the globe Earth model exist without downward acceleration? I wouldn't know how to answer that. I mean, they say there's no downward acceleration in free fall.
It's a simple question. Can it exist without a downward vector?
Oh, no.
Right. So if you test reality and establish that there is no downwards vector, then that's the end of the model. Correct?
Okay. Yep.
So I've heard a couple of times you stating some things, Jeran. Have you established whether there's a downwards vector?
Yeah, I think it's been shown.
Well, can you cite me something?
The work that they've done with the Venn diagram generator, that there's 100 volts per meter that goes up quite high in the sky.
I mean, electrostatics being in the atmosphere is not the question. I'm asking, have you demonstrated that there's a physical downwards acceleration?
No, I don't think that things in free fall accelerate.
So when I drop an object, does the object move towards the ground?
It does move towards the ground, yes.
So that's a claim of an acceleration, Jeranism.
So it's a what?
That's a claim of an acceleration in a particular vector.
Yeah, I disagree. I think that we've been pigeonholed into that belief, but I believe there's something called momentum. I believe that anything falling has to be going faster in the second after it's the first second, and it has to be going faster in the third second than more than it was going in the second because it's gaining speed.
Yes, so you believe and you claim that there's an acceleration towards the Earth?
If you're talking about increase in speed as acceleration, then yes. But if you're talking about F equals ma, that there has to be a force to accelerate, then I disagree.
Jeranism, let's take it simply. Is it your position? Are you still a flat earther?
Absolutely.
Is the Earth stationary?
Absolutely.
So when I hold an object and I let it go, it's a stationary object now accelerating towards the ground.
It starts to fall because there's a downward vector, and then it's going to go faster in second 2 than it went in second 1 due to momentum.
Right, so your claim is that there's a downwards acceleration then?
Sure.
So why does no accelerometer detect that acceleration downwards?
Because you have to be outside of that frame of reference.
So I need to be outside of a car or a enclosed system that's moving in a particular direction to detect that it's in motion in a particular direction. Is that your claim?
No, because it's not in free fall and it's not going in the direction of the vector I just mentioned.
So what do you mean it's not in free fall? What's the difference in this free fall Jeranism? Because if you're claiming that there's an acceleration downwards, you're now trying to nullify it by saying it's a free fall. So what's the difference? Because it's very simple. If it's a stationary,
in the direction of the vector.
I'm still speaking. What do you know? What does a vector mean, Jeranism?
Change in direction? I don't know. Directional.
A vector is magnitude and direction, which means something's moving in a particular direction.
Correct.
Yes. So if I'm standing on a stationary earth with a stationary object in my hand, how does it have a vector?
Because of the electrostatics in the world.
So the electrostatics are moving downwards towards the earth.
They are setting the down direction, and then the relative density of the item decides where it displaces.
Mm-hmm. So how can I not detect that acceleration downwards?
How can you not detect? Are you talking about by the scientific world, F equals ma and all their rules and regulations?
A simple do you know what an accelerometer is?
Yes.
So why does an accelerometer not detect the downwards acceleration?
Because it's been preset that the phone is moving down at a certain direction.
No, I'm not talking. Take a digital accelerometer is the only digital part of the accelerometer is the numbers on the screen. The mechanical parts inside work on displacement because when force is applied to matter, there is no force known to man that can accelerate all states of matter simultaneously without displacement. That's how an accelerometer works. So if I use an analog accelerometer, like a vessel with water and air in it, that tells me when a force is present because there's a displacement between the gas and the liquid. Now in free fall, there is no displacement of the gas and liquid, no acceleration detected. Why?
Because that's the direction that things go.
So is it your claim that gas... Is it
Down. One second. I don't mean to...
Sorry, Nat.
Okay, go ahead.
Is it your claim then, Jeran, that you can accelerate gas, liquids, and solids without them displacing?
In the downward direction or in another direction?
Any direction.
Sure. No, you have to. If you move something in a direction that's not the downward vector, then you're going to get displacement.
So only in the downward vector you don't get displacement.
That is correct.
So that's the very same rhetoric as a globe earth then, Jeranism. They want us to believe that there's a downwards acceleration that's not detectable, and the claim is that you can accelerate gas, liquids, and solids without any displacement whatsoever. That's pseudoscience. That's a claim of fantasy. Can you qualify that claim by showing it in any other vector?
I just said that it only happens in one vector. You're like, would you just show it in another vector? No.
Right. So you understand that you're special pleading.
How?
Because you're making a claim that's not demonstrable.
How is it not demonstrable? If we know that there is 100 volts per meter going up, we can change the polarity in a Van de Graaff generator, making the polarity flip, making things that are very, very light, like iron filings or whatever, go the opposite direction. Yeah.
So you're claiming that electrostatics can accelerate gas, liquids, and solids without displacement. That's your claim.
No, my claim is that the electrostatic sets the downward vector, and then if something has no weight, no density at all, it would just sit there. So it needs to have some density, at which point it displaces and goes in the direction of the downward vector.
But gas, liquids, and solids are different densities, and your claim is that they all move downwards at the same rate?
No, not gas. Gas is different.
But if I release Jeranism, I don't know if you're aware of the tests that we've done. So if I have a vessel with water in it, and I'm letting helium bubbles into the water from the bottom, and the helium bubble is now rising through that water, the instant that I let that go, the helium bubble freezes relative to the water, and now the whole system, according to you and according to the globe, is now moving down, including the helium.
Right. It loses its relative density difference, right? Because you.
But I thought you just said that apart from helium or apart from air.
What?
You just said a minute ago, except from air. No, I've just given you an example where the air and the helium does stay relative in the system, and your claim and the globe Earth claim is that the whole system, the gas, the helium, the water, the solid, are all accelerating at the same time.
No, the globe has a belief in gas, and we have a different belief.
So what's your belief about gas?
That gas expands in all directions.
Right, and do we have a gradient of gas on the Earth?
There's a gradient, yes.
What causes the gradient?
It could be pressure, or it could be it does have something to do with the density of the gas. It does have, like, some gases are a little bit heavier than other gases, so they're going to generally be lower than the other gas, but there's also a constant mixing of atmospheric gases, so you wouldn't expect to see a perfect layering of gas.
But there's a pressure gradient.
Yep.
So how do you create a pressure gradient?
Usually you have to be in a container.
Yeah, but how can I take our gradient, I can take our orientation, Jeranism, I can take buoyancy and density, and I can invert it and change it in any direction. I heard you talking earlier about science, right? No, I'm talking about physics. I'm talking about changing all variables. I'm talking about changing the vector to any vector you want, and I can recreate the conditions of our reality. Can you do that with electrostatics?
I guess that's the way the world works, but I'm wondering what you mean by that. So you're saying you can take that gas that you just talked about, the helium bubbles rising to the top, and you can move something to the right, and you can cause the helium bubbles to go to the left?
I can cause the helium, but air moves the direction the force is going in. So I can, if I've got a vessel standing here and there's an air bubble rising and a lead weight sinking, if I now accelerate that system downwards, the air bubble now moves towards the ground and the lead weight towards the sky.
Right. You've eliminated their ability to move.
No.
You've basically erased the downward vector.
Yes.
Right. So then it sits in the middle of the water.
No, that's in free fall. I'm talking about actual downwards acceleration and what happens in physical downwards acceleration. When we physically accelerate downwards, we get an inversion of the pressure gradient and the buoyancy and density gradient. So it flips 180.
At what?
It flips 180 degrees.
At flips, or are you saying it flux?
It flips.
Flops. Yeah, flips. Flops, flips.
I don't know. I'd have to think about what you're talking about. I don't really get what you're saying. I guess.
So, can I just paint a picture? Oh, go ahead, Del. I don't mean to interrupt.
Jeranism, there's nothing about the conditions of our reality that we can't demonstrate in any other vector. So if we're talking about science and we're talking about hypotheses and changing variables, then I'm standing on solid ground. So far,
how are you changing the direction of the vector to the right or left?
By using motion.
What do you mean? It's already been set. How are you changing the electrostatics of the world?
No, Jeranism, we're talking about changing variables. So again, I'm going to ask you.
One of the major variables is the electrostatic force that goes down, and you just said you could just move it in another direction. So go ahead and prove that. No, you said you're scientific. Prove that. Then. Show me that you can change the vector to go to the right. Yes,
I've already done it. That's not my problem. You're just incredulous to what I've already shown. So I'm going to put it back to you, Jeranism. It's your responsibility, son, to change the vector using electrostatics, because you can't. You're making a claim of something that you cannot isolate and change in any way, shape, or form.
I didn't claim to be able to change it. You did.
But that's part of science, Jeranism. You have to be able to manipulate and change the variables.
Yeah, and sometimes you can't. How are you going to change the variable of the direction of the electrostatics?
That's not my problem. That's your problem.
Okay. Well, it can't be done.
That's because it's nonsense.
So if there is an actual 100 volts per meter electrostatic force that's going from the top down, you're saying because we can't flip that and make it go to the right, that we can't talk about it or something?
That's because you're utilizing that in regards to our vector and the conditions that we have, Jeranism. You're attaching it to a downwards vector with buoyancy and density and these sorts of things. Now, if that's what you're claiming and you're claiming it can create these things, then demonstrate it in some other vector.
It can create what things?
Buoyancy and density, pressure gradients.
I don't think we need to change its direction.
Listen, see in physics, if I make a claim that something does something, I have to be able to manipulate that.
So what happens if you can't?
It's nonsense.
What do you mean it's nonsense? So change the direction. Change the direction of the sun. If you think the sun
I can just make any claim.
Hold on a second. If I say the sun's going one direction, you're saying I have to be able to flip it in order to say that.
No, if you're going to make claims about the physicality of the sun, then you're going to be duty bound to demonstrate that.
Well, yeah, but you'll never be able to flip the sun. It's never going to go the opposite direction. So therefore, we can't say anything about the sun.
We're not talking about flipping the sun. We're talking about physics.
There's some things in the world that are the way that they are, like hot goes to cold. We don't have to flip it and show that we can move cold to hot. It's just a natural law. It's just the way life works.
Is it?
Yeah, that's how life works. Just like pressure goes to non-pressure. You're basically saying unless we can flip it, we can't make determinations on the things that they are.
Jeranism, you're conflating two totally different things. You're talking about intangible phenomena, that being the sun, right? I'm talking about physics. We're talking about motion. So right? So when I drop a vessel and buoyancy and density ceases in free fall, what happened?
You are going in the direction of the vector. Therefore, there's no longer a vector. There's no longer a reason for anything to displace.
So it's all accelerating in a particular direction simultaneously.
The bottle, the ping pong ball, the spring, yes, everything's going in the same direction simultaneously.
Let me just read something out here quick, right? Anybody can go and check this. Special pleading. The allegation of special or new matter to offset the effect of matter pleaded by the opposite side and admitted as distinguished from a direct denial of matter pleaded. Misleading argument that presents one point or phase as if it covered the entire question and issue. Let's get another example of special pleading. Special pleading is an informal fallacy wherein one cites something as an exception to general or universal principle without justifying the special exception. Now, in this case, Jeranism's special exception, just like the globe Earth, is that there's a magical physical downwards acceleration that's not detectable.
No. Read the definition again. Read the definition one more time.
Special pleading is an informal fallacy wherein one cites something as an exception to general or universal principle without justifying the special exception.
Okay, I didn't do that.
Yes, you did. You said
there's no exception to general or universal rules. I'm talking about the general and universal rule. There's no exception to it.
So let me highlight where the exception is. We do not have access to any force where we can demonstrate the acceleration of gas, liquids, and solids simultaneously without a displacement occurring. Now, only on the downwards vector, you're pleading that that's the case, which you've done so a number of times already.
Because it's the general or universal way of the world. What did you say? Read the definition again.
I'm not talking about opinions, Jeranism. I'm talking about in physics.
Well, I'm asking for a definition right now. I don't want your opinion. I want you to read the definition again.
No, I'm giving you.
Yeah, you don't want to read it because you realize that in the definition is the answer, and you're just going to pretend like it's not.
See, what's being clearly obvious here is
why don't you read the definition again?
This guy is one of the most disingenuous.
Why don't you read the definition again?
One second, everybody mute up. Everybody mute up. I'm going to step in right here. Okay, Del, can you read the definition again? And then let's just go one by one, please, if we can. Okay, and then if you have a problem with the definitions, Jeran, then point it out after Del is done reading. Thank you. Go ahead, Del.
Special pleading is
read the definition one more time?
Special pleading is an informal fallacy wherein one cites something as an exception to general or universal principle without justifying the special exception. Right. So a universal principle is an accelerometer, where an accelerometer detects the presence of force. It detects
universal principles. An accelerometer, a man-made device, is now a universal principle.
It's force. It's how force acts on matter. It's a universal principle. Yes.
The universal principle is that hot goes to cold, low pressure to no pressure, and things go down because that's the direction of the vector. That's all universal principles.
I know, Jeranism, but you keep saying the vector. You don't comprehend a vector's magnitude with direction.
I don't give a fuck about words. I know what I'm talking about.
So now you don't care about words. So now you're just being arguing up against a wall. You're disingenuous liar.
The downward direction. If vector is the wrong word, then you know what I'm talking about.
No, I don't, because you say words don't matter. So,
No,
listen,
I said
Jeran,
if you have a problem with vector, then what is the downward direction? That is the direction of free fall.
there's no detection of a downwards acceleration. Nobody can detect downwards acceleration.
Okay, can I step in? Can I step in real quick?
Wait, so hold on. I'm going to ask you a real quick question. Are you talking about if we drop a car from the Empire State Building, it's going to stay at the same speed all the way down?
What do you mean stay at the same speed?
Stay at the same speed.
There's a change in velocity.
Okay, so is that not a acceleration?
Yes, it's a change in velocity is an acceleration, but the claims
you just said we cannot show acceleration.
Listen, Jeranism, an acceleration is a change in velocity, right?
Okay.
So see if I'm moving up the way, right, at 10 miles per hour, and then I slow down to 5 miles per hour. That's an acceleration. I'm still going in the same direction.
Okay.
Right.
So you just said, repeat what you said one more time, that we can't show a downward acceleration?
You can visually interpret the downwards acceleration. However, physically, you cannot detect that that's what's happening, because the detectors do not detect the downwards acceleration that's claimed to be there.
But the item does go faster as it falls.
No, it just appears to you like that. See if you were on a train side by side, another train, Jeranism, right? And both trains were doing 100 miles per hour. And then the train to the side of you slowed down. It looks to you visually like that one went backwards.
Okay.
Right? So visually, you can interpret things visually, just like you can interpret train tracks are converging in the distance visually. But you know physically that they're not, because you measure them.
But you're on the train. What if you're outside the train? You would know which one is slowing down and which one's not, right?
You're changing reference, But the two train scenarios, just like you within the reference frame. So when you hold an object and you drop it, you interpret that goes physically downwards.
Correct.
Right, visually. However, if you now attach an accelerometer to that, which detects a force present and which direction the force is going in, it will not display for you that the force went downwards.
Right. Is an accelerometer man-made?
Well, it doesn't matter how you make it.
No, it doesn't matter.
No, because look, Jeranism, when a force is applied, you cannot accelerate. Can you accelerate gas, liquids, and solids without them displacing?
Can you accelerate? Yes, as long as it's in the direction of down.
Can you do it in any other direction?
No, because you can't erase the downward vector.
Right, so you can't.
I don't want to use that word anymore. You can't erase the downward direction.
Let's take it step by step. The reason why you can't do it in any other direction, why can you not do it in any other direction?
Because it's a general or universal principle.
What is?
Downward, down.
Yeah, we know that the assumption of down's there.
What?
Yeah, there's an assumption that there's a physical direction of down.
Right, because there always would be, right? No matter which direction it was, we would be living.
We're trying to establish if that's actually the case.
That there's only one down direction?
No, that there is a physical downwards acceleration. So the upshot is you claim there's a physical downwards acceleration, but we can't detect it, correct?
No, I don't claim that. I don't know what you're talking about. You stop saying what I claim.
Right, so is there a physical downwards acceleration?
If you're talking about acceleration being a change in velocity, then things that are dropped in the downward direction get faster because of momentum and they change velocity, so therefore they're accelerating.
So you're claiming there's a downwards acceleration?
Yes.
How do we detect it?
Measuring distance over time.
And how's that going to tell us that there's a magnitude and a direction of something physically moving in a particular direction?
Because if you drop a car off the Empire State Building and measure how far it falls in the first 20 floors, and then the next 20 floors, and then the next 20 floors, it's going to be going faster on the last 20 floors than it did on the first.
But if I attach an accelerometer to the car, it detects no acceleration.
Okay, what is the accelerometer made of? Is it a man-made item?
Jeranism. Listen, it's
when I ask you questions, you just blow air and you just want to move the direction. You're not answering. Okay. You're not getting anywhere.
There's two things. Either you're really, really ignorant, or you're just plain dumb. And if you're really ignorant, I suggest if you're really ignorant, I suggest that you learn. Right? Because I'm trying to educate you, and you just don't seem to want it. You seem to be fighting for the sake of fighting.
Well, you seem to be fighting for the sake of fighting.
No.
You have all the truth. You're the arbiter of truth. You're the physics expert. We should all just bow to you and listen to your explanation of downward directions.
No, but I can demonstrate how an accelerometer works.
How? I asked you what it was, and you couldn't tell me.
Because when force is right, Jeranism, can you provide me a force that can accelerate gas, liquids, and solids without them displacing?
How many times are you going to repeat the same thing?
Because you're going round in circles, ignoring it.
Didn't I answer it? Did I not answer you already?
Only in a downwards vector, right? So you're special pleading for special circumstances.
Sorry, that's a general or universal principle. Again, you're not getting it.
It's a general or universal principle that the Earth's a globe vibrating and gyrating through infinite
Who said
space.
that? Who said
Well, that's
that?
a general principle, is it not?
Not according to me.
Well, not according to me. And when you're just saying then, Jeran, so see how disingenuous you are.
How am I disingenuous? You said that I'm going for special pleading, whatever the hell that is. Okay, well, I'm not, because you said it's an exception to a general or universal principle.
Well, can it be demonstrated in any other direction?
No, nobody's
right. So it's special then.
No, it's not. It's a general or universal principle.
It's a general or universal principle that the Earth's a globe in outer space.
Okay.
Right. So what's your point?
What's your point? You brought it up, not me.
You're the one that's saying general principles and stuff.
That's in your definition, dipshit. That's your definition.
Listen.
All right, I need to step in a little bit.
Disingenuous cretin you are, son.
Yeah, I'm sure. Yeah.
Okay. Okay. So the first
son.
What?
1 second, Del.
Right,
1 second, Jeran. Please.
Yes.
So the first thing to do is again, I think we have to get back to the point of accelerometer. Now, let me ask both of you guys a question. Del and Jeran, do accelerometers exist? Yes or no?
The man-made item, yes.
Yes, they exist.
Okay. So when you say man-made item, Jeran, is there a different accelerometer that we need to discuss? Or is there an accelerometer that we can all agree on? That's the first thing to discuss.
There's lots of different kinds of accelerometers.
Right.
Okay. So what are 1 second, Del? 1 second, Del, please. So if there are different types of accelerometers, can you just tell us what they are and how they differ?
I'm sure there's electrical ones. I'm sure there's pressure ones. I'm sure there's magnetic ones. I'm sure there's tons of ones.
Okay. Yeah. So there are different mechanisms of an accelerometer.
There's not?
No.
What do you mean?
Okay, why not? Well, not that. 1 second, Jeran. Why not, Del? Why is it not true? Go ahead.
Because an accelerometer works on the fact that when force is applied, you cannot, unless two different states of matter or two different bodies are rigidly connected, when force is applied to one, there'll be a displacement because force is not multifaceted. There is no force known to man that can apply itself to various states of matter simultaneously in order to apply varying amounts of force in order to accelerate different states of matter simultaneously. It's nonsense. The reason an accelerometer works is because you can only apply force to one aspect and the other one, due to inertia, will remain in its position and we will get a displacement. That's how an accelerometer works. They all work on the same fact.
Okay, stop there. Jeran, did you understand it? And do you agree or disagree with that? What Del just said?
No, I don't think there's a reason I have to agree with a man-made device that he's claiming can or can't do something.
Is wind a man-made device?
Is what?
Is wind a man-made device?
One what?
Is it wind? Wind.
Oh. No.
Right. So if we've got natural things in nature like wind and it blows on something, right? Two different pieces of matter, then the two pieces of matter displace relative to each other as the wind applies force to them. So that's how we comprehend accelerometers. That's how we devise them, because we comprehend that force cannot act simultaneously on all states of matter simultaneously. So it's taken from the natural world. That's how they work.
I'm assuming that's how everything works. Okay. So we take accelerometers from the world that we see, and then we measure whether or not something's moving. Correct?
Mm-hmm. Yep.
Okay.
And the reason we know is because when force, do you understand the word force? Jer, I don't mean to be
talking about the scientific word force.
Just what's force to you?
Okay. Action.
right? And force is something external to something else acting upon it.
Oh, could it be something inherent? And I mean, there's nothing external to me that's causing me to push something. It's me doing it.
Well, that's your will.
Yeah, but you are the external force.
Will and volition are a whole other, discussion. But obviously, you comprehend that there's a life force in you that gives you the ability to move.
Correct. Okay.
Right. But when we're talking about inanimate matter requires something external to it in order to make it move. Correct.
Okay.
Do you agree?
Well, again, if you're talking about a rock dropped from the top of an Empire State Building, I don't think it necessarily needs any force causing it to accelerate, because it's going to get faster in second 2 than it was in second 1.
Hey, but hang on. So inanimate matter, it's just as simple. Can inanimate matter move by its own volition, or does it require an external thing acting
it
upon
requires
it?
an external force to push it off the edge or whatever.
Now, when I stand on top of the Empire State Building holding a rock on a stationary Earth, which means the Earth's stationary, I am stationary, the rock is stationary. Now I remove my hand from the rock. It's your claim that the rock now accelerates.
It's my claim that it goes in the downward direction because of its disequilibrium with its.
So from stationary to moving as an acceleration, correct?
Okay, yeah, according to you, yes.
Yes. So that means there's an external force acting.
Not according to Jeran. Let me just step in. What Jeran is saying, and you can disagree with this, is that there is no force applied to the rock that is falling. It's just falling because of buoyancy, basically. Am I understanding you correctly? That there is no force?
Yeah, I believe that
on
they
the rock?
misapplied momentum. Yeah.
Right, but momentum is something that's already in motion. On a stationary Earth, standing on a stationary building, me being stationary with a stationary rock, there is no momentum.
Okay, because it hasn't left your hand yet.
So once it leaves my hand, it must accelerate.
Right. Well, unless the air balances it out. But yes, for the most part, it's going to accelerate.
From stationary to moving as an acceleration, I don't know how that's difficult to comprehend.
That's fine. It's just, but you're talking about words and what we associate with them. It's not universal. It's not like God didn't place the word acceleration here, and then we have to follow this exact rule. It's just your.
That's fine. If you want to get hung up in the words, we don't need to get hung up in the words.
Okay, good.
It's simple to comprehend. If something's stationary and then it moves, that's an acceleration. It's not difficult.
I agree with you. We'll call it acceleration.
Yes. So we understand that acceleration of inanimate matter requires an external force.
Okay. Now, if let's say that item then started to fall at just a universal speed, or it just was falling at its terminal velocity, you're saying then that there is no acceleration?
No, because if it's stationary and I remove my hand, then it's by default that position now has to claim that that's moved from stationary to moving, which is an acceleration. Acceleration.
But it could be a 0.1111 second acceleration, and then it's done. You're saying that the acceleration just keeps going or something?
No.
Oh, okay. So I agree with you that it accelerates from the split nanosecond that you let it go. It's got that tiny bit of acceleration, and then that's it. The rest is momentum.
No, momentums can't provide acceleration. Momentum is a rate that it's going at.
That's what you believe. That's what you're.
No. Don't listen. Don't misrepresent. At no point have I claimed any of that Jeranism.
You just claimed it right now. You just claimed it right now. I'm saying I think that when something is dropped, because it has to go faster in second 2 than it went in second 1. So therefore, momentum is making it go faster. You're just assigning the word acceleration to that, and then making rules that acceleration has to follow.
Momentum
use that word then.
But momentum's not a force, Jeranism.
Oh, of course not. According to science, it's not.
Of course, it's not.
Well,
Force is what causes momentum.
Okay.
Momentum is our language to describe something, right? We're talking about forces and actual physicality.
Okay, so if you're on a big ramp, there's a huge ramp, and you're at the top of it with a car, and you just push it a tiny bit with your pinky, just give it a little tug. Okay, now from that point on, the car will accelerate down the ramp, correct?
Well, there's a change in velocity, yes.
Okay, So what is the force causing the speed to change?
The upward push of the Earth.
The what?
The Earth pushing upwards.
On a ramp?
Yes.
I asked, what is the reason the car gains speed? And you said because the Earth is moving upwards?
Listen, right, if you're on Earth, right, just listen to this, right? If we're in a reference frame that's moving, say, 1,000 miles per hour, right, uniformly. Now, to us within the reference frame, we're at rest and things appear stationary because everything's moving at the same rate. Okay? You understand?
Sure.
So when I now have a car on an inclined plane which is connected to the Earth, right, and I release the brake of that car now has the inertia of that car is present. There is nothing to push against the car because you've got it in an inclined plane. Now that car now starts to lose the speed that it had as the Earth continues to push up past it.
Yeah, I guess I don't get why would that cause the car to go faster?
What do you mean faster?
If you're on a ramp and you push a car down a ramp, it's going to be going faster in the second leg of the ramp than it went in the first leg.
Yeah. Because there's a misunderstanding of what I'm actually saying to you, Jeran.
It's not a matter of what you're saying to me. I'm asking you a question.
I'm trying to get you to comprehend. I gave you the example, right? If you and I are both on two platforms right now, moving upwards at 100 miles per hour, right? And your platform slows down to 50 miles per hour. To me, visually, it looked like you went downwards. But you didn't. You're still moving upwards at a slower rate now.
Mm-hmm.
So visually, I can interpret that you went down.
Sure, unless somebody from the outside was able to see it.
Yes, but none of us are outside of the Earth's reference frame.
Okay.
So I'm just trying to get you to comprehend visually how we can interpret things.
So isn't what you're just saying is just another explanation, and nobody would be able to know which one is true unless we were on the outside looking in?
No, because the accelerometer detects the upward push.
The accelerometer.
Yes.
So hold on, let's go back to the two platforms. We put an accelerometer on each platform. You're saying that we could read from the accelerometer and determine that one of the vehicles simply slowed down, or one of the platforms.
If I have, like, say we've got a vessel on each platform, Jeran, right? And my platform's doing 100 miles an hour. Now, in this vessel, we've got an air bubble that rises at a set rate, okay? Now, my platform, whatever speed my platform is moving at is going to be related to the speed that the air bubble rises through the medium.
Okay.
Right? Now, I can show you this. I can accelerate, the vessel and increase the rate of buoyancy, right? So that tells us the direction that a force is going in. If you've got an air bubble in a vessel and you accelerate it in any direction, the air bubble will move towards the direction that the force is going in, right? So when we set a simple bottle on the table and we see air bubbles rising, the air bubbles are shown as the direction the force is traveling in.
What?
Now, I can demonstrate that to you by changing the direction in any way you like. If I accelerate it downwards now, the air bubble now moves towards down. If I accelerate to the left, the air goes left. If I accelerate right, it goes right. If I accelerate left diagonal, it goes left diagonal.
Okay.
The separation of these things shows us the direction a force is going in. So now when I release that, as the air bubble's rising and I release it from free fall into free fall, so it's no longer connected to the Earth, so the motion transfer is no longer felt, it's no longer present, the air bubble stops moving through the water because there's no compression there anymore. As soon as I now apply a force to that in any direction, immediately the air now starts to move through the water in that direction.
Mm-hmm. Yeah, and downward is different than every other direction.
And I can do it also with any other material. I can do it with a flame. If you've got a candle and a flame shape that's going upwards, if I now accelerate that candle downwards, guess what happens? The flame goes towards the direction of acceleration.
So then if you spin a flame on the outside of a rotating disc, well, the flame goes to the inside. So you're saying the acceleration is on the inside then for a spinning?
That's centrifugal. Yeah, well, I was talking about linear motion, but if you want to talk about centrifugal, we can talk about that, but it's not related to what we're talking about right now.
No, but it's just, if you're going to use the flame in one example, then it would have to work in the centrifugal example. But actually, a centrifuge pushes things to the outside, not the inside.
Does it?
Yep, that's how centrifuges work.
But a centrifuge is a pseudo force. It's not an actual force. The actual force is the actual rotation of the platform. The effect that we experience is a pseudo force. It's not an actual one.
So what makes something a pseudo force?
Well, an effect of force. So when you go on a roundabout, there's levers and mechanisms that cause that rotation. That's the force. The force that's there is the pressing of one lever against another lever.
Okay.
Now you have inertia, and a rotation is a constant change in direction, which you experience as a force, but it's not really.
Okay. So, I mean, does that apply at all to this idea of dropping things from buildings or being on platforms?
It's all related because it's mechanics and it's physics. You know, force is external to matter. All forces are pressure.
Here's my issue, though. It's just, if you're going to bring up pseudo force now, in regards to, I'm just wondering, is there any pseudo forces when it comes to items dropping, things rising? There's no pseudo forces there. Everything's an actual force.
Well, of course, you know, as I say, when things are connected to the earth, we have buoyancy and density. So there's a force present. As soon as we remove it from the earth and put it in free fall, the air cannot push against it the same as the solid ground can. So we have a ceasing of buoyancy and density and pressure.
Correct. The same thing as why water in your glass sits in your glass, because it cannot accelerate down. It can't go down because there's a bottom of the glass there.
Yes, and when I accelerate the glass downwards, what happens?
Well, if you're accelerating it faster than the downward fall is, then you're going to get a displacement up.
So how can I accelerate faster than the downward fall? What rate's the downward fall?
According to them, an average of 9.8 meters per second.
So 9.8 meters per second is roughly about, 28 meters in a second.
Yeah, I don't really know if I believe that necessarily. I've never done a test myself to prove it.
So if I apply an accelerometer to even 10 meters over a second, I get a massive display of acceleration. But
how much is it comparable to 9.8 or no?
Well, I'm shortening it. I'm giving it more leniency by shortening the distance. If I say, right, there's a 10-meter distance now, and in the space of 2 seconds, I want you to accelerate something over the space of 10 meters within 2 seconds, which is heavy lenient towards this claim, then you're going to see a massive display of acceleration within the accelerometer. But yet, we've got a claim of 9.8 meters per second from both globe and stationary flat earthers with absolutely no detection of this downwards acceleration. I find that highly incredible.
Yeah, I would have to think about it. I mean, there is gravimeters that supposedly measure that. Now, I'm not making any claim on that. I've never used one, never seen one. But there's claimed use of gravimeters, which you can take around, that drop little items inside of them and supposedly come back to somewhere near 9.8 meters per second squared.
Yeah. There's other tests you can do, Jeranism. There's a few videos you can go and watch right now where somebody has.
So are you saying that there is or isn't 9.8 meters per second squared on the Earth?
Well, this is the thing. I don't claim there's a downwards acceleration, so it's different for me. If you go and look at these videos, you can get a guy that has a meter-long test tube with a liquid in it, right? And he drops a ball bearing into that liquid. Now he times the drop and he markers the beaker with lines, and the spacings are equidistant. There's no acceleration of the marble through the liquid.
Yeah, I think that's because of the atmosphere. That's because of the air, right? Air slows things down from falling.
No, it's a liquid. It's in a liquid.
Well,
so it doesn't. If you accelerate through a liquid, it doesn't matter. If you're claiming an acceleration through a liquid, an acceleration should still be witnessed. Now,
but not 9.8 meters per second.
Well, when he drops the ball bearing into the top of the meter-long test tube, he markers the test tube by increments all the way to the bottom and times it. There is no increase in speed or acceleration of the marble through that liquid.
Okay, but there's no claim that there is an acceleration in water.
But so water's not accelerating down. Nothing's.
I don't know. What are you talking about? You're talking about a sitting body of water that has an ocean floor. Then no, it's not accelerating downward. It's stopped.
What's keeping it down?
It's density.
Density is not a cause of weight or direction.
Oh, here we go.
It's not though. Explain to me how density is a cause of direction.
You said it's not a cause of weight.
Or weight. How is density a weight? What is weight?
Because I'm more dense than my sun, and so therefore I weigh more.
What is weight?
Weight is how much density we have pressed to the earth due to our density and due to the downward direction of the electromagnetic force.
So you need two factors then, right?
I don't know what factors you mean. It's
weigh
weight.
yourself in air. How are you going to do that?
In air?
Yes.
Go stand on a scale.
In air?
I don't know what you're saying. Air?
Look, I'm trying to get you to understand. You're saying weight. Listen, weight is not a property of matter.
No, it's because it's density or not medium dependent.
Yes. So you need two factors. You need something pressing against it. So if I put you into a centrifuge right now, Jeran, and you were pressed against the wall with a set weight, and I now accelerate that, your weight increases.
Correct.
Right. So weight is not relative. It's not a factor of matter.
No, it's a factor of matter based on its medium. And it's acceleration or it's non-acceleration, or if you're in a centrifuge or not, right? That all is going to make a difference.
Well, we agree that weight's not a property of matter.
Okay.
Right.
It's an attribute of it.
Yeah. So what causes the water to stay on the earth?
Density.
Density. What does density do? How does density tell things to go down?
Because it displaces, because it weighs more than the air it's in, and it has to go in some direction. The direction it goes is the one where the electrostatic force points down.
Right. So electrostatics can direct density.
It sets a downward direction.
Can you use electrostatics to set a different direction?
Yes, you can use the Van de Graaff generator to flip the polarity, and you can get things to rise instead of fall.
Can you use a Van de Graaff generator to change the direction of buoyancy and density?
I just said yes.
Can you cite me a video that shows that you can change buoyancy and density using a Van de Graaff?
Sure. You mean show you a iron filing going from the ground to the ceiling?
No. You know, if I've got a vessel with water in it and an air bubble rising and a lead weight sinking, and the air bubble
you would need a massive change in the electrostatics. Massive.
So
this is 100 volts per meter. That means every 3 feet, it's another 100 volts. How are we gonna generate the flip of that?
So you can't change it, right? That's fine. I accept that, right? That's the same as the globe Earth. Now, when I say to the globe Earth gravity, and I say show me gravity in some other form, they say they can't because they need a big enough planet. They need to escape the Earth and show us a different planetoid in order to demonstrate it. You're now saying the same thing.
Yeah, I don't know what to tell you. I mean, you can't change that direction. So you're basically saying that when there's a universal law, something that God placed the way it is, that because we can't flip that, what are you making noise for? Can you shut up for 3 seconds?
Because here we go to the God of the gaps. Now you're just jumping to an argument that that's just the way it is. No. That's not how it works here.
Okay, so why does hot go to cold?
Because of pressure.
Then why does pressure do that?
Temperature and pressure are both intricately related.
Okay, so what causes low pressure to go to high pressure or high pressure to go to low pressure?
Because of the push of the earth. The only reason we have that pressure is because of the motion. But listen, let's not jump. Let's get back to that point again because it's hugely significant. And I hope that you're intellectually honest enough to own it, Jeranism. Just like the globe Earth, they cannot isolate and demonstrate what they claim, and you cannot do the same. You're now saying it's just the way it is. That's your excuse.
What are you asking me to demonstrate to you?
We spoke about electrostatics, right? And I asked you, can electrostatics alter the buoyancy and density gradient? You said yes. Then
yes,
you said,
take an iron filing. Hold on, you can take an iron filing that on Earth will go to the ground. Great. Yeah. We can put it in a Van de Graaff generator, flip the polarity, and then the iron filing now goes up. So we just did exactly what you asked for.
I can use a magnet to levitate metal. Does that now mean that it's magnetism that's responsible?
If you're asking me to use magnetism, you asked me to use electrostatics. So we use a Venn diagram generator. Make up your mind. What do you want me to show you with?
But it's your claim is electrostatics is responsible for the conditions of our reality. So that's why I'm talking about it.
So then I said, put it in a Van de Graaff generator.
Right. So can you use a Van de Graaff
magnetics?
Can you use a Van de Graaff generator or magnetism to invert buoyancy and density to change its direction?
I just said yes. With an iron filing, we can do it in a Van de Graaff generator. By flipping the polarity, it rises.
So you can take an accelerometer and use a Van de Graaff machine in order to change the accelerometer's direction.
What do you mean change it? No, an accelerometer has weight. It weighs a lot. What is with all the noises you're making? It's like.
I'm not making noise.
You can act like a petulant wee child all you like, son. You're just exposing yourself even more, which is
I'm
great.
exposing myself that you can't shut up when you ask me a question. And everything I say, you answer with. That's you, not me.
That's fine. Because I'm disgusted at the behavior, to be honest.
Oh, yeah, this behavior is disgusting that you're asking me for something and I'm providing it. You say, can we flip it? And I say yes, and I show you, and then you bring up magnetics.
Okay.
You've been nothing but confrontational since the off and defensive.
Oh, boy.
All right, one second.
You're attacking what my belief is, but you don't have a good attack on it. So
Jeranism, your beliefs are ridiculous, and I'm exposing them.
My beliefs are ridiculous. You think the Earth's moving upwards, dude?
It's demonstrable fact.
Oh yeah, it's demonstrable. Yep, Earth's flying upwards.
The difference with me and you is I can qualify my position. You clearly can't.
Sure, you can by just words and what you've been saying and definitions.
By physics,
acceleration and stuff.
By physics. All you have is a power trick of a Van de Graaff machine, and you think that qualifies it.
You asked if we could switch it, and I said yes. That's how we show you.
So what was asked is, can you flip buoyancy and density in a vessel, that being an air bubble rising through the water and a lead weight sinking in the water?
How the hell would you do that? You'd have to flip the polarity of the Earth. You'd have to flip 100 meters per 100 volts per meter. Think of how high the Earth goes. So how am I going to flip that much electricity and put that on the ground and flip it the other way?
Right. So your claim's non-demonstrable. You can't falsify it. You cannot falsify it in any way, shape, or form, which is the exact same as the globe.
Show me something that moves upwards naturally out of nowhere that just does it like the Earth you say it does.
What do you mean?
Well, you asked me to show you proof of so I'm asking you to show me proof that something can move upwards naturally with nothing's moving it up. It just happens to be doing that. So show me another example.
How's that related to the point that was just made?
I'm asking you to give me an example of your belief. And if you can't show me that it's demonstrable, you can't do it. You can't show it. Then you're just like the globe who can't show gravity.
My position can be demonstrated in any vector you like. I can change all the variables and I can change the direction, any direction you like. So that's my position. What?
So do it to the left then.
It's done.
How?
It's already done.
How?
By using motion, because motion's the cause of pressure gradients and buoyancy and density.
So how do you erase the downward direction when you move something to the right? How do you erase? So you're basically saying that in order for me to show you what I believe, you need me to cancel out the current thing and show you it in another direction, correct?
Yes, I can cancel out our position because I claim it. Because I can accelerate it to the opposite direction that it's going in, and I'll get an inversion of the effect.
So what's different? I don't understand what you mean. So how are you doing that?
By using motion.
Okay, so why can't you use a Van de Graaff generator?
Because can you change buoyancy and density relative to each other, the direction that they go in using a Van de Graaff machine?
No, you need a more powerful one.
Exactly. You can't. I can.
So you're saying you can show me acceleration and buoyancy change in any direction? Yes. Like to the left or right. So what do you explain that? I know you can't show me, so just explain what you mean.
I can, helium, you understand helium moves upwards. Yes.
Do you want to share a video, Del? Do you think a video demonstration could be?
Let me just hear what he's saying here. I'm trying to follow what he's saying. So
you bring the videos up. You bring the videos up. Yes, I can use motion, Jeranism. So a helium balloon, which you would obviously understand, it's got a buoyant effect applied to it, pushing it upwards.
Correct. It's because it's less
So
dense.
I can change the direction that the helium goes in by motion. So I can put helium into a vessel and accelerate the vessel in any direction, and the helium will move the direction that the force is going in.
But it's already going up, right?
But I can make it go down.
How do you do that?
By accelerating the vessel downwards. If I've got a jar with a helium balloon rising and a lead weight sinking, right, and I now accelerate it downwards, the helium balloon now moves towards the ground and the lead weight towards the sky.
Yeah, I don't understand what you're saying, because aren't you just doing go ahead.
Yeah, Del, can I show the video by Level-Headed William? Do you think that would be helpful?
Wait, you talking about the water bottle with the sprinkler, with the spring in it?
No.
Okay.
No, not that one. The helium balloon in the pan.
The one with the spring's also a really good one to make the point. But yeah, Nat, show the video you want to show.
Show me. Like, don't think I'm following.
Yeah, it'll be short. I just kind of fast forwarded so you can see what's going on. William is going to explain it. Go ahead and watch it for a second.
Sure.
You need to get the bit before
have
that.
A cargo van as the container.
What?
You need to get the bit before that.
Well, okay. So I'll go back a little bit. Okay.
Okay.
Natch, you need to show him the bottle first.
Yeah, I'm showing the bottle right here.
Yeah, you need to show that first. Yeah.
A water bottle as the container, and the camera mounted onto the reference frames that I'll be accelerating, which is the dolly. The reason why we have to constantly accelerate to recreate buoyancy is because we're connected to the Earth, which is already in constant motion. And in order to overcome constant motion, you need constant acceleration.
Can I ask one question?
As you can see,
so can you just real quickly explain to me clouds? So what's going on there?
Clouds are part of the density gradient, part of the pressure gradient. But it's just like why helium rises. Why we have these layerings. These are all part of the system. And again, we can display how a pressure gradient and buoyancy and density is created by motion, because the antecedent to these things is force, which is motion. So
So I'm confused. So the cloud that's in the sky above me, it's the Earth is moving upwards, but the cloud is staying an equal distance away from me. Yeah. What is pushing up on the cloud?
What do you mean? What's pushing up the cloud? There's a layer of density of air beneath them.
Okay, well, if I hold a piece of paper out next to me, there's also a layer of air under it, but it will fall.
Yeah, because of the material that it is, the air can't push up against it. It can to a degree, just like a parachute.
Well, the air pushes clouds up, but it doesn't push a piece of paper.
Well, it does. It restricts its deceleration rate. If you make the surface big enough, if you utilize a parachute, you can change that variable and change the deceleration rate. It just depends.
I think you're being a Poe or something. You don't really believe this. There's no way you believe that a cloud is being pushed up by the column of air underneath it, but that doesn't happen to a piece of paper.
Well, what is a cloud, Jeranism?
A bunch of water?
As a helium balloon gets pushed up. What's causing it to get pushed up?
It has less density than the air it's in.
And what does density have to do with motion?
Because there's displacement. Where the fuck is it going to go?
Well, what's pushing it up?
Nothing needs to push it up. The air underneath it pushes it up.
Well, exactly.
Right.
So you've just answered that the air's pushing it up.
Right. So a piece of paper, if I hold it here, it falls because it's more dense in the air, correct?
Yes, because the air can't push it up.
Why not?
Because you just answered that.
No. I'm talking about your model. You say the ground is moving up.
Yes.
Clouds are staying an equal distance away from me. You're saying that the reason that the cloud is being pushed up and staying in the same exact spot is because of the column of air underneath it's being pushed up, yes?
Yep.
So why isn't the column of air lift the piece of paper?
Because it's too dense.
Okay. Well, then it's the same belief I have.
Okay.
So you believe clouds are denser than the air beneath them?
Clouds are denser than no, they would fall.
And that's what I'm saying. So it's obvious the clouds are less dense than the air beneath. The paper's more dense than the air that's surrounding it. So the air's pushing past it. It can't keep pushing it up.
Okay. Can I just interject real quick?
Yeah,
we can continue with this.
Okay, go ahead. Sorry.
Yeah, that's fine. Like basically, like your position, Jeran, if the Earth is continuously pushing up, then we would be like getting closer to the clouds, as far as I understand that what you're asking, right?
Well,
and what I think that
the clouds and the stars and everything, yes.
Yeah. So what Dell is.
Sorry.
Go ahead.
Can I just clarify? I need to ask a question. Is it your position, Jeranism, that the Earth system and the things that we call the luminaries, the heavens, are all separated?
We are the basement of the universe and everything rotates around us.
And are they separate from each other?
Are they separate from each other? I don't know what you mean. They're all part of the world, but are they separate like the star isn't connected to the Earth? Yes.
Yeah. So they're not connected to the Earth?
Correct.
How did you start
energetically?
So you believe then that the stars, the luminaries, are separated from the Earth?
Do you mean energetically or do you mean physically?
What do you mean? What's energy?
I don't know. Energy is force from a distance.
Right. So force. So force is a connection between two things.
I think that the stars might have effects on us. Yes. So I don't know what you mean by connected.
Well, is there a void between the Earth and the stars?
A void is in a vacuum?
Yes, like nothing between them.
No,
nothing connecting them.
Probably some liquid that they're in.
Right, so that's what I'm saying. If I have a vessel with lights above it and a water in a tank and I push it upwards, then they're all connected. So why would you think one would crash into the other?
Well, because if you're talking about the air being what is connected and then the whole bottom is moving up, then all things would be affected by that same column moving everything up.
Yes, and they are.
Right. So an airplane is moving up when it flies by the air below it, even though it's more dense in the air.
Well, the airplane's using constant thrust. It has to keep using thrust in order to maintain that distance. Like a helicopter uses thrust to hover above the Earth.
Correct.
Do you think if we were in an elevator moving upwards and I took a drone off and hovered the drone, that the bottom of the elevator is going to hit the drone?
No, it's operating within that system.
Exactly.
Okay.
Right. So there's your answer. So let's continue with the video.
So, but hold on. But if you dropped a drone, it would fall and hit the ground, right?
Well, the drone would lose its momentum upwards because it's moving upwards with the elevator. So the drone would slow down now and the bottom of the elevator would connect with the drone as the drone still moves upwards.
Yeah, I guess what I'm saying is I think you're just taking a contrarian position. You're just saying that the things that it's kind of like what Albert Einstein did with relativity.
Please don't strawman me.
What?
Please don't strawman me and just call me a contrarian.
Okay, let me call you something.
Qualifying everything that I'm saying. I'm speaking to you.
Qualifying everything by saying it's equal. It's equal and opposite. Like basically, Einstein said that you could either call it gravity or you could say it's the opposite. The Earth is moving up at 9.8 meters.
Yeah. Well, in Einstein's equivalence principle, which is the similarity between the globe Earth and the stationary Earth, in Einstein's equivalence principle, he talks about how if we were in a moving reference frame linearly, or we were in a gravitational field, there would be no way for us to tell the difference. Right? However, one of those is demonstrable and one is not. We can utilize motion, linear motion, to demonstrate these things. We do not have access to gravitational fields, things that can accelerate uniformly gas, liquids, and solids. These are mathematical propositions. It's an interpretation based, which is what the globe has done. The globe required physical downwards acceleration. So it takes optical phenomena, that being Neil deGrasse Tyson letting a mic go and saying gravity, see. Right. So optically, they interpret that the microphone went downwards and then start claiming from there's a physical downwards acceleration due to this imaginary field. Now, in the equivalence principle, one postulation, that being motion, physical motion can be demonstrated and can recreate the conditions of our reality. Nobody can demonstrate a gravitational field. Nobody can manipulate a gravitational field. Nobody has access to this in any way, shape, or form. It's a mathematical proposition.
So you're saying that all gravity around the Earth is the same?
No.
Okay,
because,
so if there's a change, aren't they representing that? Aren't they showing that?
Yeah, well, you know, we've got air, right, and we've got fluctuations in the air. So you understand that if I'm on a scale inside a vacuum chamber and I weigh 18 stone, now as they vacuum the air out of there, my weight increases because the upward push, the buoyant effect, is no longer felt anymore. So we get an increase in what we call weight. Now, as you move around the Earth with fluctuations in temperature and pressure, you will get microscopic variations, which is what they get. Microscopic, depending on your altitude, air temperature, and air pressure. These things play a role.
Right. So why does the electrostatic explanation of that not work?
Because the electrostatic explanation is one and the same. I cannot detect the physical downwards acceleration other than to interpret it as an optical phenomena. When I test for it physically, no detection of that acceleration is present.
But can you detect that there is a change in the electrostatics?
What do you mean?
If we went up and checked at 40,000 feet, would there be a different voltage than at 5 feet?
Probably.
Okay. So then we did verify that there is a gradient of electrostatic force. Okay.
Well, again, no, there's a gradient, but a gradient, the antecedent to any gradient is motion. Look, you know, I don't discount electrostatics in any way, shape, or form. I'm trying to get people to incorporate it into the investigation. It's simply not the cause of our conditions. Again, if it is the cause of our conditions, then you should be able to demonstrate it. But you can't.
It's not the cause of the conditions.
Right. So what causes the conditions?
There has to be a down.
There has to be a down.
Correct. If you're going to have displacement and things have to go in a direction, then they were going to go one direction or another, and whatever direction everything goes in would be where we would stand, and we'd be having this conversation talking about where down is.
Right, but down's just our directional.
That's what my point was: is that it could be any direction. We would just be there, living there, calling it down.
Yeah, but it's optical. That's the difference between optical and physical. So again, optically, you can interpret down, things go down, but physically, it's not there. That's not what's happening. Just like optically, I can assess that, the sun appears to go down, train tracks appear to converge. These are visual interpretations. When we move through these things physically, like a train track, we have provable integers that are directly measured, showing that the train track spacing does not alter. So we know optically we have an issue. It's optics that's causing that phenomenon, not the physical world. So the same when we drop things, we have an optical interpretation of physical down. Okay. But physically, it's not there. It's not actually what's physically happening.
Because why? What's your evidence of that?
Because it's not detectable.
It is detectable. We see that it's going down. We wouldn't even be talking about it if it wasn't detectable.
But optically, Jeranism, relative to you, optically in your coordinate system of optics, you're the stationary point, you're the point of reference. So you're saying down is a direction relative to you, up is a direction relative to you. That's your coordinate system.
Okay.
Right? Physically, it's not what's happening.
Okay, but you're just going to say that we're moving up, and you're going to put yourself into the world, and you're going to say the ground is moving up, and this, right? So you're just saying
because I can detect that.
Just like we could detect a change of anything dropping.
Yes, there's a change when we drop things. There's a change in velocity.
Okay.
Right, but the claim of a vector is the important part. So nobody disputes that when I let an object go, there's a change, right? The claim is that the change is that the object physically accelerates downwards. That's the problem.
The claim is it falls downwards, yes.
Yeah, but with the claim attached to that it's accelerating downwards. Again,
you're just using words that may not be describing exactly what's going on. If you're talking about acceleration, do you mean it constantly accelerates?
Listen, it's the vector that's in question. Nobody, listen to me clearly. I do not, just like you, deny there's a change when I let an object go. Okay. We clear so far?
Okay, yes.
Right. The problem is that from, say, your position, when I'm sitting here holding this object in my hand right now, it's stationary, correct?
If you're holding it, yes.
When I let it go, does it go from stationary to moving towards a stationary earth?
Yes, but let me just see something. But aren't you just saying that the same is true, only you're saying that the ground is moving up? So you're just saying the opposite of the thing falling and hitting the ground is you're just saying the ground moves up.
Nope, that's not what I'm saying.
Okay, explain to me what you're saying.
When I'm holding the object, it's moving at the same rate as me in the reference frame. When I release the object, it loses that velocity.
Which causes it to optically look like it's moving faster.
What do you mean? Yes, it's an acceleration. It's a change in velocity. So optically, the optical part is people interpreting that the object physically moves downwards, not optically, physically. Let's separate it.
Okay, why can we not say the same thing when I drop an item?
Say what?
That it's falling down.
Because you're claiming that that's a vector.
No, I'm not claiming that. I'm just claiming it's falling down.
Yeah, but right. So let me clarify your position. You then claim that I let the object go and the object moves from its position it was in towards the earth, correct?
Yes.
Right. So from stationary to moving is an acceleration and it's a direction.
Yeah, it's 3:45. It's too much for me. I don't even know. I don't get why we're just having word arguments over, you keep bringing in acceleration and then we have to almost surmise things because you use that word. You're just playing into their traps and playing into their words. This is the problem I have with Bob. Bob always said F equals MA. And he would say, that's like a universal. We can't change that. I'm like, no, that's man's interpretation of things.
No, when Bob said that, in regards to language, I mean, again, you're straw manning me, Jeranism. It's very, very simple.
I wasn't talking about you, so how am I?
But I'm going to help out. What Bob said. F equals MA, and it may help you to comprehend this. And I hope I'm not being condescending, but I think there's a real lack of comprehension.
Maybe.
So F equals MA. Force equals mass times acceleration. So when you understand the use of language, all we have in reality is physical change, motion. Okay? So what we observe is motion of matter, a change. Now we quantify that as the word force. So force is ascribed to mass times acceleration. So they quantify force by how much mass moved over a particular distance and how long it took. Right? That's all it is. So what they're actually...
There is no force. If you're talking about dropping an item, they say there's no force there's no acceleration in free fall.
Mm-hmm. But that's the problem that I'm trying to convey to you. If an object's stationary, whether you're on a globe earth or a stationary earth, and then the claim is that the object moves, there has to be force because matter does not move by its own volition. Force is the thing external to matter that presses upon matter and makes it move.
Yeah, I just don't believe that. I'm sorry. I mean, you could drop an item and I don't believe there has to be a force. That you dropped it, you let it go. If you want to call that a force, that's fine. But from there, the item will accelerate because it's moving, it's momentum.
Momentum's a part of something already in motion. How can you have momentum of a stationary object?
I just said you dropped it, you let it go.
So what makes it move?
It's denser than the air it's in.
So density is a force?
Sure.
Right. How are you going to qualify that? Extract force from the density then. Show me how you do that.
Because there's disequilibrium, which causes a change. It has to displace. It's not in equilibrium. So it has to go in a direction and it goes in the downward direction.
That's just an assertion. It has to. This is physics. Physics is when an object matter moves because something external pressed upon it to make it move.
What about when I drop an item? If I'm holding an item and I just let it go, you're saying, where's the force that's dropping? My hand releasing something now is the force?
No, I'm not claiming that it's going down. That's your problem. I'm claiming that it's still on its way upwards and losing momentum because there's no force acting on it anymore.
So things basically all float.
No.
If I hold a rock out in front of me right now and I let it go,
Yeah.
It's floating.
No, who said that?
Well, if the ground is moving up to meet it and it's not falling, then what the fuck is it doing?
Still moving upwards. Listen, see if I'm in a glass elevator, right, and I'm standing in a glass elevator, and you're outside of the glass elevator, and I'm holding it.
Del, you're free to believe the Earth moves up. Have fun with that.
I'm trying to clarify Jeranism, right?
Because I disagree with your belief.
Get over it. Let me qualify, right? If you're standing outside observing me in a glass elevator moving upwards, and I'm holding an object in that glass elevator, and I let the object go, you see from the outside that the object I dropped still moves up, right? But what happens to me inside the reference frame is I see it visually as if it goes down, but it's still moving upwards at a slower rate than it was in the first place.
Okay.
So that's what I'm saying. When you let an object go, like if I'm holding a glass of water,
what I'm saying is you can just say you're just saying the opposite. You're just saying,
no, I'm not.
Okay.
No, I'm not. I can qualify every single thing I'm saying using physics.
By completely just opposites.
No, by demonstrating it physically.
It's not demonstrating if you're just doing the opposite of it. You're just saying, oh, it's not actually falling. The ground's moving up.
Wow.
That's what you're saying.
No, it's not what I'm saying. You continue to straw man me through this. I've not done that once to you.
Yeah, not once. So if you're saying that, if I'm saying an item is dropping, you're saying, no, it's not. The ground is moving up, correct? That's just your claim on everything. So no, you can believe that. What do you mean no?
Because Jeranism, let's get back to your point again. You're claiming
if I'm standing here and I've got a rock and I drop it, I'm saying the rock has density. It's going through its medium that doesn't hold it up until it hits the ground. You're just saying, that's the ground moving up with everything and it's going to meet the rock.
So let's clarify, is density a force?
Jesus Christ.
Well, if I'm standing here with an object, right, and it's stationary, has no vector, right?
No, it does have a vector. Every item has a vector. Every item is going down, my friend.
Yes, and a vector, the antecedent to a directional vector is motion, Jeranism. It's the antecedent.
The antecedent to a vector direction is what?
Motion.
This is not getting anywhere, gentlemen.
Yeah,
we are. But do you mind just? Can we just show the video and then talk about it a little bit, and then I'll let you go. Yeah, can I like 8 more minutes maybe? You know. And Adele, just hold on tight, please. Let's just watch this video real quick, and then I'll let Jeran go.
Centered, which means the bottle is level and the camera mounted onto the reference frames that I'll be accelerating, which is the dolly. The reason why we have to constantly accelerate to recreate buoyancy is because we're connected to the Earth, which is already in constant motion. And in order to overcome constant motion, you need constant acceleration. As you can see, the air bubble is centered, which means the bottle is level and at rest. The air bubble will always be displaced or pushed relative to the motion of the bottle. When I accelerate the bottle, the pressure of the bottle pressing on the water creates a pressure gradient. The water is then able to push anything that's less dense, like the air bubble, in the direction of acceleration, which is what we will call buoyancy. You can't have buoyancy without a pressure gradient, and you can't have a pressure gradient without a contained system that's in motion. For the second buoyancy experiment, I have a cargo van as the container, a helium balloon, and an apple. I also have the camera mounted onto the reference frame that I'll be accelerating. As soon as I accelerate, the pressure of the van pressing on the air creates a pressure gradient, with the most dense air towards the back of acceleration and the less dense air towards the front. The air is then able to push the helium in the direction of acceleration because it's less dense, but the air cannot push the apple because it's more dense, therefore the apple remains at rest. The apple only appears to move in the opposite direction of acceleration because the camera is also moving with the reference frame. The helium balloon has true motion, and the apple has apparent motion.
Wait, what? That's just false.
This is the point. This is the
thing.
Okay. This is the bit that
Okay. Now, one second. Let Jeran speak. Can you explain
Can you try and explain that to me? So he just said that he's showing the movement of the balloon, and then he said the apple's not moving when clearly it was. So can you rewind it or explain what the hell he's talking about?
Because you don't understand the visual interpretation.
And that's why I'm asking. That's why I'm asking for an explanation, Del. When people don't understand, they ask for an explanation, dipshit. That's what I asked.
I'm going to explain it to you.
Okay, gentlemen.
I asked Nachi to just. I can't even understand your language, dude. So Nachi,
Del, one second, sir. Del,
your son.
That's not an insult. That's called a fact. I can't understand what you're saying. Do you not understand
I can't understand your stupid backward reasoning. But I'm still here.
Oh well, sucks to be you.
Gentlemen, one second, gentlemen. Okay, Jeran, can I explain to you what I see? So we just go back a little bit, and then I will pause it, and then I will explain what I understand. Okay.
Therefore, the apple remains at rest. The apple only appears to move in the opposite direction of acceleration because the camera is also moving with the reference frame.
Okay, so what I believe that William is saying is that it appears like when you look at the this, so like it actually the van is moving, but the apple is maintaining its position. So if the van is moving to the left, right, its original position was in the middle, right? But as the van is accelerating to the left, it still maintains its position in the middle, relative to its original position. Does that make sense, Jeran? Did you understand what I said?
Yeah, I mean, I guess, but it's held by a string.
Yeah, but I mean, like, obviously, it's held by a string, but like, it's moving in the opposite direction to the acceleration because that is its original position. It's trying to stay in its original position. Does that make sense so far? That's what he's
in the real world. I see what you're saying. So you're saying the apple's maintaining its spot in the real world, even though it's held by a string. So because otherwise it would leave out the back of the van, right?
Yeah. It would have to be rolling around the floor of the van, I guess. But this is just for visualization.
I get it now. What you're saying.
And then, okay, good. And then, Del, do you have anything that you want to add or clarify based on what I just said here?
Yeah, it's exactly that. And if you invert that, that's what I was trying to explain earlier. The apple the apple now appears as if it goes the opposite direction, so that would be falling. But in reality, the apple's not. The helium balloon's the actual thing that is moving because there's a pressure there. It's being accelerated towards the direction of the acceleration because it correlates. The less dense material will be pushed in the direction of the acceleration.
Right, but so I guess where I'm confused is that if it's a van of air, right, which is what it is, then everything that's happening is a result of the air being shifted, right?
No, the air stays. Correct. The air stays where it was, and there's a compression of the air.
Air.
Yes, the air stays where it was. The van's the thing that moves. So there's a compression of the air towards the back of the van, the opposite direction of the acceleration, which causes the buoyant effect, pushing the helium balloon forward. That's how the displacement happens.
The air doesn't travel with the van?
No, the air has inertia just like the apple. So the air stays where it was relative to the van, and when the van moves, it causes a compression of the air at the back of the van, which causes a displacement of the helium, pushing the helium forwards.
Okay.
I mean, okay, before you say, okay, does it make sense to you? Like, for example, like if you look at this van, like the apple and the air are going in the opposite direction. And because the air and the balloon have a relationship and the air is compressing to the right, and that's why the helium balloon being less buoyant goes to the left. Does that make sense or not?
Yes. Did you say that backwards? Or the helium balloon goes to the right, right?
No, the helium balloon goes to the left, according to our perspective. The air is trying to maintain its.
Isn't the car going forward? Isn't the car going to the right?
The car is going to the left. The direction of acceleration is to the left. Look at the arrow.
I see the arrow. I was just looking where the driver was. Okay, gotcha. So he's backing up.
Yeah, it's backing up. He's backing up. So the apple and the air wants to stay in its relative position, which is in the direction away from the acceleration, and the balloon is going towards the acceleration because the buoyancy relationship between the air and the helium balloon. I'm not sure if I can, Del agrees. Del, do you want to add to that? I mean, does it make sense what I just said, or do you want to clarify it more?
Yeah, it's due to inertia. This is the whole gambit. When there's force applied, we see this gradient created because the inertia of all matter, is prevalent. So as the inertia of the air takes effect, it causes a compression, which creates what we call buoyancy and displaces the helium.
Yeah, that's where I'm confused, though, is we can't turn this sideways and do it, because if we did, then the apple's no longer connected to the roof.
Yes, we can do it in any direction. It's all been done. Jeranism. We've done it.
I just explained why you can't. So instead of saying you can do it in every direction, correct me. I said if we turn this van to, say, facing upward, then we have a problem, because the apple can no longer be tied to the place it's tied.
Yeah.
How's the apple going to sit there?
It would have to be tied in a different way. It would have to be tied in a different way. Like if you're talking about just flipping at 90 degrees and then it's like going upwards and it's like a rocket, then you can still create a pressure gradient. No?
Yeah, but I'm saying the activity that's happening here is happening because there is a downward direction. That's why the apple's hanging. That's why the balloon is attached to the bottom of the van. It's all dependent on either the gravity or what we would call density and buoyancy.
But see, the thing is, so if you take it on the vertical, the up and down thing, right? So if we have the van like that, we have the apple at the bottom of the van, and we have the helium balloon on its way up through the van towards the sky. Okay. Now, if we start moving that van upwards towards the sky faster, the helium balloon rises faster.
Okay. Because the air is being pushed to the bottom.
Yes, because the air's compressing at the bottom.
Okay.
Like on the Earth. That's why we have a gradient of air here. Okay. Just like in the van here scenario.
What would the apple do?
The apple would remain where it is because the air can't push on
it. Yeah, but go ahead.
1 second. Del, let's just imagine a rocket, that it's accelerating down to the Earth, and you have unlimited amount of space, right? Yeah. And there's air and balloon and an apple inside that rocket, just like a container would, like this container would. Then would you surmise that because it's actually accelerating to the ground, and it's going faster than, let's say, gravity pulls it, it's actually going faster because it's a rocket going downward. Would you have the same effect of the density gradient where the balloon is actually towards the bottom, pointing towards the ground, and the apple actually will be at the top in that gradient? Yes or no?
Yes, this is what I'm saying, that we've done all this, downwards acceleration and an inversion of the buoyancy density gradient. Yeah.
Okay. All I needed is all I need. 1 second. All I needed is a yes. Jeran, do you think that's possible or that's plausible, or do you disagree with that idea?
So go ahead and lay it out again. There's a rocket. It's coming down towards the Earth, and it's got inside of it a helium balloon that's got no string. It's just a helium balloon.
Yep.
Yeah, just a helium balloon, air, and an apple, and then it's moving down to the Earth faster than the gravity can actually pull it. So it's going faster than the free fall.
Okay, so gravity. So then the apple would be pressed to the top.
Yep.
Okay.
And the helium balloon would be probably at the bottom, because the helium balloon is less buoyant than the air, which would be pressed to the top, just the same as this experiment right here.
Okay, I agree with that.
Okay, good. Then we both are on the same. We're all on the same page with that, right? Okay, Del, did you want to say something more?
No, I mean that's the whole point. This is how accelerometers work. This is what it shows us when we see these displacements. The displacements are the effect of a force being present, and we can tell the direction the force is going in by the displacement of the buoyant effect. So helium balloons moving in a particular direction, air moving in a particular direction, shows us the direction the force is going in. You can qualify that by demonstrating it to yourself in any vector that you want. That's that's just physics.
You're saying helium balloons go up, and so therefore you can surmise that the Earth is going up because all direction follows the.
Yeah, and I can test that because we've done tests. I don't know if you can pull up Williams one with the helium balloon attached to the spring. If you could, Natch. So in the container of the box, the helium balloon stretches the spring, so the helium's pushed to the top of the box and it elongates the slinky. So you can see there's a buoyant effect. Now, when you release that box into free fall, the air has no compression anymore. So the only force present is the tension of the spring, which contracts, showing you that there's no buoyancy anymore because the force is no longer present.
Let me give the opportunity to Jeran first. Like, in your opinion, like, what do you think is happening there? Like, when you see this balloon actually falling, and then the
Well, the
like,
same
obviously
thing we talked about with the rocket, right?
okay, yeah.
Right. So,
Which is what?
So the air is being pushed to the top of the box.
Yep.
Okay.
And thus,
What?
and so,
And
Sorry.
so what? I'm sorry. I thought you asked me what's going on here. So if the air is pushed to the top of the box, then the balloon would be pushed down.
but hang on
Okay.
a minute. Hang on a minute, because earlier on it was a claim that everything's being accelerated downwards at the same rate, which means the helium balloon, the spring, the box, and the air within it should now all be accelerated down at the same rate. There should be no change whatsoever.
What do you mean? The air is dropped?
Earlier on when we were talking, you clarified and you made the statement that everything is being accelerated downwards at the same rate.
I never have said everything is being accelerated downwards at the same rate. So don't act like you don't strawman me and then go ahead and misquote me. I never said that.
I'm pretty sure if you rewind, that's what you said.
I said every item is downward accelerated.
So you know, when I say there's no displacement of the accelerometer in free fall, you say that's because everything's going the same direction at the same time.
No, I'm saying that there's no. If you're talking about, I was giving you the globe explanation.
All right. So what's the stationary Earth explanation then?
For what?
For why, you know, buoyancy and density all ceases in free fall?
Because whatever you are dropping, right? So in that case there, you're dropping the box, you're dropping the balloon, you're dropping the air, I guess, right?
Yeah.
Well, the air is being carried down with the box, correct? Is
Yes.
the air right? So the air is
I would say so.
Right. Well, it's just the same thing as the van. We just watched the van. The van pulls forward. The air, you said, is trying to remain in its place.
Mm-hmm.
So if you drop a box, isn't the air trying to remain in its place and the box is compressing?
So everything's not accelerating downwards at the same rate then?
Everything is accelerating downwards at the same rate.
If the air was to stay where it was, so would the spring and so would the...
Here's what my question is, like the air that's next to my head right now. So you're saying that I think that the air next to my head is being accelerated downwards?
Oh, is it? What's causing the gradient?
I don't know, but it's not accelerating downwards.
So again, when I've got an accelerometer, an air bubble rising through water, and a lead weight sinking in the water, and I let the vessel go and that ceases, the air stops rising and the lead weight stops sinking. You said earlier that it's because everything's now moving at the same rate towards the air.
Got you. So you're saying that the water should try and remain in its same position?
Well,
I guess my problem is there's nothing that's going to push the items inside the water in a different direction, right? So if you're dropping a bottle of water and inside of it are items, now the items right now, if I'm just holding up the bottle, they have density, they have weight, they'd be going down to the bottom of the glass. If I drop the glass, then everything is moving, the glass, the water in it, but the water is just hitting the top, right? So there's no, what's going to cause to go through and push the items somewhere? There's nothing.
That's the point. There's no force. But again, when the air bubble was rising through the water, going upwards, and I let it go, it stops on its ascent through the water, right? So it should be the same in the box there then. Because in that example...
No. Water doesn't compress like that.
Right. So when if I've got a standing bottle in front of me and there's an air bubble rising through the water, why is the air rising through the water?
Because it's less dense and the water's going down and the air's going up.
Right. So again, in the box scenario, that should be the same. The helium balloon should stay in its position because the air's still there. But now you're wanting to say, no, the air stayed still while the box all moved and compressed the air at the top of the box.
Yeah, but then you're saying that gas is the same as liquid, which I don't believe.
Eh? Gases and liquids are both fluids.
Okay, but if I have a glass of water sitting next to me, the water is going down. It's trying to get out of the glass going down, but there's a bottom of the glass which is preventing it from. You making noise again?
Sorry, it's my partner coming into the.
Oh, I thought you were just making poof noise again. So I'm just saying, if I put a glass of water next to me, the water is trying to go down. But right now, sitting next to me is a glass empty. The air is not trying to go down.
So air's not going down, but we have a pressure gradient.
Correct. Yeah. Well, I mean, I'm saying it's not going down because it's also all stacked on each other. Right. So there's air everywhere in this room. It's not like the air from the top of the room is trying to get to the bottom. It's just all the same weight. It's all the same density. It's all the same air. It's all the same collection.
It's all the same weight and it's all the same density, but there's a gradient, there's a reduction in pressure the higher we go.
Yeah.
It's not homogeneous, air. There's a gradient to it.
Correct.
Right.
Well, and it's also, but it's not just a gradient based on weight and density, right? Meaning that the air around us is nitrogen and oxygen or whatever. Argon, right? But I'm saying those three things have different weights. We don't have a gradient of all the heaviest gas at the bottom. Do we?
I don't know what you mean. There's just a gradient. There's a pressure gradient.
Okay, so do you think that the heaviest air is at the bottom of the earth?
No, the air's just air.
It's not made up of individual ththings?
Well, this is a whole other investigation.
Okay, I thought that's what you were getting at. I thought you were trying to say.
No. I mean, if you take these things like we talk about.
Is air all the same thing? Then you would understand why the air in my room is not trying to get from the top of it to the bottom.
No, but there's a gradient to it.
Okay, in my room.
Yeah.
Yes.
Well, no, not in your. Well, maybe not particularly, not a small amount, but we do understand that when you're at lower altitude, the air is heavier than if you are in the Himalayas, right? I mean, like that's true or not true?
It is true, yes. But I'm saying it's not a matter of which one is. There's just less of the collection of air, correct? At the higher altitudes. Meaning, what are I always forget. What are the types of gases in the air? Nitrogen, oxygen, carbon dioxide.
Yeah, something like that. Yeah.
Okay. So, but each of those has a different density, but they don't line up according to that, which they would, I guess, if you had some sort of a either a gravitational belief or you had some sort of even a moving upward belief. I'm guessing. Why would it? Wouldn't you say? So, do items have? So the weight of items then is simply their ratio compared to the Earth moving up, or how would you describe that? How would you describe weight?
Weight is matters, what we call inertia. It's its resistance to motion. So as the Earth presses upon it, depending on the rate of the Earth, just like if you were on an elevator right now and that elevator was moving at 50 miles per hour, and you stood in a scale and say you were 18 stone, and I now start accelerating that elevator upwards, your weight increases because inertia is a factor of matter. So,
and if we had a bunch of rocks in the elevator with us, as you accelerated it more and more, they would also organize themselves based on their individual densities or their resistance to movement.
Yeah, their weight would increase. If we had a scale under them, then you would see an increase in what we call their weight. But the weight's not a property of the matter at all. It's a relationship between the resistance of motion and motion.
Right. So if the Earth is moving up, okay, good. I don't want to. Basically, that would be straw manning you because I'm just going to basically ask why doesn't the air separate out by the same way the rocks would? But it's because there's something called the cycle, basically the gas cycle.
It does. I mean, if you know, you understand, Jeran, if you were in a swimming pool and you had a beach ball, you know through that experience, if you try and take the beach ball to the bottom of that water, you can feel the push of the beach ball. You understand that? Yep.
You mean the push up?
Yes. So imagine right now you're standing at the bottom of a swimming pool holding a beach ball.
Right.
You can feel that push upwards, right?
Correct.
So if I then had that swimming pool with you in it holding that beach ball, and I had it connected to two cranes elevated off the ground, and then I disconnected those cranes, and that now went into free fall, instantaneously that push that you're feeling from that beach ball ceases.
Wait, start again. So you said if I'm in a pool with a beach ball at the bottom.
Yep.
Okay, and there's a crane pulling up on the beach ball, or what is it doing?
Well, just if a static crane, has a swimming pool elevated off the ground, right?
Oh, the swimming pool itself is off the ground.
Yes, and it's connected to the crane, which is connected to the earth. Okay. And as you stand at the bottom of that swimming pool, you can feel the push of that, right? Yeah. As soon as the crane disconnects the swimming pool and puts it in free fall, instantaneously, you no longer feel buoyancy. It instantaneously vanishes.
Okay, because when it's just hanging from the crane, then the water is much more dense than the air in the ball, and it's trying to get under the ball, which is what I feel pushing up. As soon as you disconnect the crane, now everything, the water, is going down. So the ball no longer has a bunch of water trying to get under it. Everything's going down together.
Right, so there we go. There's the clarification of that claim. Get back to the test a minute ago. Your claim is that everything moves simultaneously downwards.
Well, not everything. The things that we're talking about. If you're talking about this particular example, when I say everything, I'm talking about everything that is contained within the pool.
Yeah.
Okay.
So just like the box experiment a minute ago, everything within there must now all accelerate downwards uniformly, like the pool example.
Except for the air is going to be pushed up against the top of the box.
Well, in that case, then the air should still push upwards in the swimming pool as it's into free fall.
So wait, is the swimming pool inside of a box?
Well, it doesn't matter.
It does matter. It's the same thing. If we open the box that was dropped, is it not different than when the box has a top?
No, we've done it with an open vessel and closed vessels. It's the same result.
What do you mean? How would you do that?
Well, we've done the tests with an open vessel and a closed vessel. The results are the same.
Okay.
So if you're in the swimming pool, right, let's enclose the swimming pool in a box.
How would you drop a helium balloon in a box if there's no top?
Eh?
You just said that you've already done it without a top. So now go back to what's his name's example and show me that without a box, without a top.
Right. Okay. Fine. So getting back to it again, the swimming pool example. Now you've just stated it that when the swimming pool goes into free fall, the helium, the beach ball, and the water, and you, and the container, the pool, are now all moving at the same rate. Now, when we show you the test there of the helium balloon stretching the slinky and we put it in free fall, you claimed then that the air stayed still and pushed the helium balloon downwards. So if that's the that claim, get back to the test a minute ago. Your claim is that everything moves simultaneously downwards.
Well, not everything. The things that we're talking about. If you're talking about this particular example, when I say everything, I'm talking about everything that is contained within the pool.
Yeah.
Okay.
So just like the box experiment a minute ago, everything within there must now all accelerate downwards uniformly, like the pool example.
Except for the air is going to be pushed up against the top of the box.
Well, in that case, then the air should still push upwards in the swimming pool as it's into free fall.
So wait, is the swimming pool inside of a box?
It doesn't matter.
Well, it does matter. It's the same thing. It's if we open the box that was dropped, is it not different than when the box has a top?
No, we've done it with an open vessel and closed vessels. It's the same result.
What do you mean? How would you do that?
Well, we've done the tests with an open vessel and a closed vessel. The results are the same.
Okay.
So if you're in the swimming pool, right? Let's enclose the swimming pool in a box.
How would you drop a helium balloon in a box if there's no top?
Eh?
You just said that you've already done it without a top. So now go back to what's his name's example and show me that without a box, without a top.
Right. Okay. Fine. So getting back to it again, the swimming pool example. Now you've just stated it that when the swimming pool goes into free fall, the helium, the beach ball, and the water, and you and the container, the pool are now all moving at the same rate. Now, when we show you the test there of the helium balloon stretching the slinky and we put it in free fall, you claimed then that the air stayed still and pushed the helium balloon downwards. So if that's the case in the scenario of the swimming pool, then the beach ball should still push upwards as you go into free fall, but it doesn't. So there's a problem in your reasoning here.
Okay, I'm trying to grasp what you're saying. So you're saying in the box example, we have a helium balloon tied to a spring.
Mm-hmm.
Okay, so it's tied to the spring because if it was okay, and you drop that. So now, what if we had the air, the ball of air? Is it also using a spring connected to the ground?
No, if you're in the swimming pool, well, if you can.
I'm just trying to make it like things so we don't just say one thing is like the other if it's not exactly the same.
See, let's clarify where the problem here is. The issue. When I gave you the example of the swimming pool and you holding the beach ball, right? And I said when it's released into free fall, you feel no push of that beach ball upwards. Okay. Then we go to the box example where we showed you the helium balloon in the spring. And you said the reason the helium balloon pushes down on the spring is because the air remained where it was. So that's given a buoyant effect, right?
Okay. Can you describe for me just real quick, just so I know what we're talking about. So in the box itself, what is the setup? Just remind me so I can think about it.
Well, Nat's just showed it there a minute ago.
Yeah, I just can't remember. So you've seen it more times than me. So I'm just asking you, it's a balloon attached to a spring or no?
Yes, it's a helium balloon attached to a slinky. And when you're on the earth, the buoyant effect is present.
Yeah, I'm just asking the whole entire thing. Is that the only thing we have in the box? Just a helium balloon and a slinky?
Yes.
And then air.
And air.
Okay. And then in the other example, being held by a crane instead of being held by William is a pool.
Yeah.
Okay, with how much water in it? Half the thing of water?
No, we can fill it to the top. We can half fill it. We can seal the lid. We can have it sealed at the top if you want, whatever you want.
And there's a whole bunch of water. And inside there, instead of the spring, it's me standing there. And instead of the balloon, I'm holding a beach ball.
Yes.
Okay.
And you can feel the buoyant effect, the same as the helium balloons showing you the spring being stretched.
Okay, I got you so far.
Yeah. And now when I release that swimming pool, instantaneously, you no longer feel the push of that beach ball. The buoyant effect ceases instantly.
It would just hover in the middle of the water.
Yes.
Okay. And then in the box, you're saying that the helium balloon wouldn't just hover in the middle?
No, because the only force that's present is the tension of the spring. So that as it's connected to the earth, the buoyant effect overcomes the spring and stretches the spring. Now, when you release the box, the pressure gradient ceases instantaneously, and the only force present is the tension of the spring, so it contracts.
Okay, so now tell me what the problem is with those two scenarios, why they show anything, or why you think they show something.
No, it was in relation to when you said that when the helium balloon won, when we let that go, you said the air remains where it was and causes a pressure on the helium balloon to push it downwards.
Well, I was asking you because I was asking if it's the same as the van.
Yeah, but
I wasn't making a claim. I don't know what.
Well, that's what I'm saying. If that was the case, then it should be the same in the swimming pool example. The beach ball should should still be visibly moving through the water as the water in the swimming pool move faster towards the earth. But it doesn't. It stays right where it was instantaneously as you release it.
Yeah. So to me, that just is a matter of nothing has weight then at that moment, right? Nothing has a weight different than the other item.
No, there's no weight to anything.
Right. Okay.
Because you need a resistance, you need motion in order to have that, what we call weight.
Right. Weight is pressing against something.
Yes, you need a force. You need a force, external force acting, pressing against something to give you weight.
Okay, I don't necessarily agree, but I see where we're at. Okay, now explain what this should explain to me. Why did we watch that? What is the conclusion I should reach?
What do you mean the conclusion? What you should be realizing.
Give me 2 examples. You just showed me the balloon in the box. You showed me the pool idea. So now I understand it. I agree with you. So now what does that tell me?
Well, it tells you when it's connected to the earth, it's experiencing a force.
When it's connected to the earth, it's.
Can I try to explain it?
You try.
I guess maybe. Okay. So, like the way I understand it is that if the earth is rising and everything that is connected to the earth that is rising, it will create the buoyancy. But at free fall, buoyancy loses its effect because it's no longer quote unquote connected to the reference frame, which we call the earth. And if you're standing, for example, on the earth, and then you're holding up that bottle or that box, that helium balloon, that box with the helium balloon inside the box is connected to you, which is connected to the ground, which is moving upwards. Now, did I explain it rather adequately, or do you have something else that you want to?
No, I think it's quite clear. There's a correlation with being connected with the earth and the effect of what we ccall buoyancy and density.
Right. Yeah, let's just make it simple. Yeah, go ahead, Jeran.
I was going to say, it could be that it's too late. I agree with what you're saying, but I don't understand the logical conclusion that should come from it. Like what you explained has not said to me that the Earth is moving up, but you're saying that if I tried to describe this using relative density, that it won't work. Is that correct?
Yeah. So let me try.
No, hang on, Natch, because it's important in this part.
Okay, go ahead, you do it.
I just feel like this is really important because the relative density part is another aspect. So this is why I came to these conclusions and these tests. This was based on flat earthers claiming relative density disequilibrium. So relative density disequilibrium,
which I disagree with. Okay.
Yes, because that's the point. If relative density disequilibrium was true, then an air bubble rising through water is a relationship between the air and the water. That being that the air is less dense than the water, so it gets pushed upwards through the medium. Correct, but that then should be the case regardless of whether it's in free fall, because the claim is it's a relationship relative to those two mediums. Correct.
That's why I abandoned that thought.
Yeah, because that's exactly why I done these tests, because I knew that you need an external. This is why the globe Earth has gravity. They comprehend you need an external force for buoyancy and density. So relative density disequilibrium should be there regardless of whether or not the apparatus is in free fall. Air should still rise through the medium, regardless of whether it's on the Earth or whether it's in free fall. But the stationary earthers, in order to get round this, go to the position of that's because everything's accelerating equally towards the Earth, which is the same as the globe Earth rhetoric. But
which is the same as your rhetoric that the Earth is moving upwards.
No, because I'm not claiming that in free fall things are being accelerated in a vector towards the Earth. I'm claiming that buoyancy and density are shown as the direction the force is going in, right? And then when we remove that from the Earth, you get an instantaneous disconnection. So the pressure's no longer there within the medium to displace the air to give us buoyancy. These guys are claiming the opposite.
I know. I don't agree with them. I don't think relative density alone doesn't explain what we see, which is why I've always said Dell has an argument with Oakley and that crew, not with the people who say there's a downward vector.
No, my arguments with anybody that claims there's a downward vector. There's a gradient of electrostatics. I don't deny that. That's That's not the issue. But electrostatics cannot, recreate these conditions.
They set the down. That's all.
How does it set it down?
Because of the polarities of the Earth being negative and the sky being positive, and then there's a downward gradient.
Yeah, so that then, in order for it to be a direction, it has to be flowing in a particular direction. So
that's what all magnetics and electrostatics is a constant flow, isn't it?
But electrostatics is a static. What how do you get a linear flow direction from statics?
Any change, isn't it? Any change going to account for that?
No, there's a change in the charge.
Right.
How do you get a linear directional flow from static charge?
You don't get the flow itself is not from the charge. The flow is due to the density of items.
Right. So then, again, use electrostatics and accelerate these things in a different vector.
Okay, I'll run that by Zach and
I had journalism. I had a little tech chat with space audits. I can't remember. Is it
Alan?
I think it was Alan, and he came to the conclusion at the end. It's this simple, right? From my position, whatever this electrostatic, this background field is, right? It's my position that we move through it. Now, on the counterclaim, the counterclaim is that we are stationary and that flows through us. That's the simplest, way to put this.
Right. Okay, but that's kind of what I was saying by just the opposite. It's just okay. So now, why is one shown to be true and not the other?
Because in your case, that there has to be that downward flow, an acceleration flow from top to bottom. Now, when we do these tests of accelerometers and various other materials, we do not detect that. We do detect it when it's on the Earth, that being that the Earth's the thing pushing through this medium. So for me, it's the motion of the Earth. The two factors, the two constants, is the background constant, which gives matter inertia, and that's the resistance to motion.
But if things are going down, if the electromagnetic field is from the high of the sky, let's say it's a ton of volts, and then down to whatever it is at the Earth, which is a downward movement or a downward gradient, then how do we know that's not what's causing the pressure? Which would then be the measurement. Then accelerometers are actually using the electrostatics to get your movement.
But then we're in a position that it's not detectable, other than optically interpreting it. Because
why wouldn't the accelerometer detect it? Because
when we drop the accelerometer, it registers nothing. There's no displacement of any matter. When there's a force applied, we get displacement of matter.
So you're saying that if we drop an accelerometer in air, it doesn't show that it's cutting through air?
Yes, it registers zero. If you use a digital one or you use an analog one, both register zero.
An accelerometer registers zero when it's dropped.
Yep.
All accelerometers.
Yes.
Okay.
If you took a skydiver and attached an accelerometer to them, it would register zero.
What about if and you're saying the same thing is true if you used a man-made one, a water bottle?
Water bottle. If you had an anvil, a huge anvil, and you by a string attached a water bottle, a basic accelerometer, and you threw that anvil off the top of a cliff, the water doesn't displace. The air in the water don't displace. It's not detecting a downwards acceleration.
Yeah.
Have you ever had a full cup of water, Jeranism, and you've dropped it, and the water stays exactly where it was?
Yeah. Again, I can explain that. I don't have any issues with that.
Yeah, I can explain it. It's because it's still on the upward trajectory. It's displaced in the upward trajectory. It's the reason why water's level. This is another aspect of it. Water being level is the result of a force acting. Now, again, force is something that presses upon things. So the very fact that we have a world with water displaced, and we have a reference to that, which is the plumb, the vertical, That's how we distinguish when something is level. You cannot distinguish something as level without a reference to the plumb, which is the vector.
Okay.
So water being level is the result of a force acting. Now, again, I can change the orientation of water level by using motion.
Okay. So okay, yeah, I guess I'm missing something. Maybe it's too late. I'll think about it and talk to Zach. Zach will usually be able to explain to me a little bit better. And then also, go ahead. I'll talk to.
I know you're getting ready to go, so I think it's good to just sit on it, and and then
let me talk to Alan and those guys that are a little bit more scientifically inclined.
Well, it's a bit of a thing with on me by saying that, Jeranism. I've spoke to these people and they cite kinematics, which is the ability to interpret things from different positions. Now, again, the thing that if you're being genuine and honest, I would suggest to you is that any of the claims should be brought into the realms of physics, which means demonstration.
Okay.
So they're going to just say the same thing as a globe says. The way they interpret it.
Well, now I don't know, man. Like, I think it's good to just let people try to figure it out. I mean, like, obviously, I believe that you're speaking the truth, but if they're not picking up what you're putting down, it's not that it does take. It's not that they're being dishonest. It's just that maybe we have a disagreement about how things are working.
Well, I mean, the truth of the matter is nobody's ever changed their mind in a moment anyway. You shouldn't be expecting that, Del, if that's your expectation.
Right. No, it's not my expectation.
Okay.
Again,
sometimes things need to be talked out. I kind of understood what you're saying, at least more than I did at the beginning. I do see some issues I need to figure out in my head. I can't really explain it. So I'll talk to Alan. I'll talk to those guys. If something is the truth and our model doesn't match it, I'm the person that's going to be voicing that. I don't want to have a belief that doesn't work. So if this is one of them, we'll figure it out.
That's fine.
That's fair.
I didn't have an expectation. I'm the very same. I started off my life as a globe Earth space believer, and then I went through a process of learning, different things to come to this position. I even had the opinion, Earth stationary and this, that, and the other, before, and I still had that resolve to correct myself and learn and move forward. So I don't expect anybody to get it in one go. I sat on this and went through this process for about 2 years before I actually came out into the open with it. So I don't expect anybody. The only thing I really expect is honest discourse. If people are claiming that they're honest and they're truth seekers, then we should be able to have these discussions.
But the problem is that if somebody has a certain idea in their mind and you are changing that idea and then basically expecting them to acknowledge right then and there, that you're going to have bad luck with that.
No, I don't. I've just clarified that. I don't expect that.
Well, it seemed like you did, but anyway, that's fine. Give me some time to look at it.
I thought I clearly explained there that I don't have the expectation. My only, my bar of reference is physics. So all claims and any claim must come into the realm of practical physics for me. That's just how I operate. I don't go on beliefs. And if things can be practically demonstrated and satisfied in that regard, then I accept them. That's it. It's as simple as that for me.
For me, I guess the problem that I'm having with it that I don't quite grasp is that you can't remove the conditions of the earth. You're saying, I can make things go left, I can make things go right. Yeah, but you're not removing what's already here. Not at all. There's still the downward direction, whether it's gravity, whether it's electrostatics. You're not removing that. You're acting within it.
No, what I'm removing is the claims of physicality. The claims that things like, gas, liquids, and solids can accelerate simultaneously without any displacement. That's a pseudoscientific, claim. That's what do you mean by displacement of what? Gas, liquids, and solids. There's no force known to man that can accelerate gas, liquids, and solids without displacement occurring. That's not reality. So when people claim that, then I have a problem with that.
Okay, you're saying because there's only one thing that does that, and that would be the things moving towards the Earth.
Yes, that's a special pleading. It's the same as the globe Earth. It's the exact same claim. The only difference is that they've removed gravity and replaced it with electrostatics.
Yeah, and the reason for that is because gravity is their only answer for why things are spheres. And when you get rid of that, you don't need things wouldn't necessarily need to be a sphere anymore. That's why we've gone that direction. It shouldn't be that difficult to figure out.
A thing that you might want to consider, Jeranism, is when you look at the globe Earth from that position, things form spheres only in free fall. They've taken no force acting. The background thing, whether it's electrostatics, ether, whatever anybody wants to call it, it's that's responsible for water forming spheres in free fall, because there's no active force acting on it. So their axiom is taken from free fall. And that's why they try and derive a force acting equally inwards towards the center of that sphere. That's where they've taken it from. But when it's applied, when things are connected back to the Earth, that's not the axiom. That's no longer present.
Right.
Because
They go to something else.
Yes, water displaces when it's in that position. So their axioms from free fall, no force acting while they're trying to claim a force.
Correct.
This is why
we have to be free falling around the sun, and why the sun's free falling around the galaxy, et cetera, et cetera.
Yes. So they ignore. They don't use the word ether. They say gravity, gravitational fields, gravitational this, that, and the other. They're talking about the same thing that other people are talking about in regards to ether. There's something that gives rise to matter and gives matter what we call inertia. And in the state of free fall, like water, liquid forms a sphere. So they're trying to extrapolate from that position, but that doesn't give you a vector. That's something different. When people are talking about vectors, we're talking about active forces. There has to be an active force present, which is why they get round it by saying it's a force, but it's not a force, and they've got loads of double speak.
Right.
But the fact of the matter is, when true force is applied, we do get displacement of materials, of matter. That's just the facts that people can deny if they like, but it's not going to change the reality. It's just a matter of people understanding where the assumptions, where the axioms are being derived from. As I say, my axioms are derived from practical physics. Theirs are derived from theoretical physics, that being making mathematical assumptions on things and then deriving, their interpretation from that assumption.
Okay, so just so I get it, one last question. So if we drop something from the Empire State Building, is it increasing in speed on its way down?
No, it's losing momentum. See if I can just give you one example in order for you to understand this, right? Sure. If you're on the Indy cars, right? If you've got two cars,
I didn't hear that. Yeah, what?
You watch IndyCar racing or Formula One or anything like that.
IndyCar, yeah.
Yeah. So imagine now you've got these two cars that are going round the track, and there's two cars, and there's a gap of 1 meter between those two cars, right? Okay. Now they're on a straight, and the car in front reduces its speed to say 90 miles per hour. Then see that the car behind has an impact that's very, very subtle, very slight, but they're both moving still forwards. Now, if you increase the gap between those two cars so that the car in front now has more time to lose the forward momentum, the impact is going to be greater. Do you understand? But they're still both moving forwards.
Yeah, okay, got you, because the car coming behind it's going to be moving much faster compared.
Yes, but they're both still moving forward. It's just that the one in front loses that initial momentum. So the impact's greater. The more distance you have, the more time there is for the car in front to lose its forward trajectory. So the bigger the impact is. Now, if you were standing outside observing that, you could interpret that the car in front started to go backwards. And that's the difference. It's a visual interpretation. Both things are still moving forwards, but as the gaps increase, the one in front has more time to lose its momentum, so there's a greater impact.
Okay.
So it's the same when you drop something. If you drop something from 10 centimetres, there's a very slight impact because the object has not had enough time to lose that initial speed. If you take it to the top of the Empire State Building, it now has more time to lose that speed, so the greater the impact when the Earth comes to meet it.
I understand the impact part. I'm not really sure I understand the speed, but I'll think about it.
It's just because it's visual. As I say, with the two car scenario, if you observe that optically, you could interpret that the car in front has accelerated.
Let's let him go, Del. He's been wanting to go for like 40 minutes now, and I do want to thank Jeran for coming by, and thanks for having this conversation. And I'm glad that we were able to, talk like gentlemen for the most part, and if we can avoid calling each other names, like especially on panel. I don't care if you do it like on your channel, that's fine. I mean, that's part of content or whatnot. But like here, when we are having a serious conversation, let's try to be cordial as much as we can. I know we are going to disagree about stuff, but that's just the way it is. So again, thanks, Jeran.
Thanks, guys.
Go ahead.
I was just going to say, I think that's a massive part that's always been here within this whole community, is that anybody that has a differing, view or comes with something different, automatically there becomes this defend-attack relationship, which I've never really understood. I think the problem comes because of my mannerisms, my accent, my appearance, that may play a role in this attack-defend thing. For me, it's supposed to be an objective inquiry. And anything that I say I can qualify, it's not about usurping anybody and becoming top dog. I'm not involved in any ego battle. The only hope that I have is that we can continue these sorts of open discourse, and we can progress from that. I don't have a gripe with anybody. I don't have any personal relationships to anybody. I don't have a horse in any race. As far as I'm concerned, we should be able to objectively discuss. If there's tensions, sometimes people have to look at their own position and why they're being defensive of that position. If it's true, we can discuss it and we can practically demonstrate the things to each other, and it's as simple as that. Another thing I just want to throw in there, maybe that will take your interest, Jeranism. You know how the globe Earth proponents have behaved towards flat earthers over the years. You know that, as far as they're concerned, we're dumb flares. And they'll take any opportunity to make hit piece videos and jump upon anybody that they think's making outlandish statements. Would you agree with that?
For sure.
Have a look, Jeranism. How many globe earthers have responded to this position of mine?
How many what?
Globe earthers have responded to this position that I have.
Oh, I don't watch them, so I wouldn't know.
None. The problem is because they know that I comprehend their model and they comprehend exactly what I'm saying. And they know that if they dare enter into that discussion, they're going to be made to look absolutely ridiculous. Because for me, and I'm going to make the statement, it's a fact, there is no physical downwards vector.
So, I have a debate platform. Why don't you challenge some of these globers then?
If you can get a glober to come on and talk specifically about gravity, and you can moderate that with respect and blah, 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 fine. Again, I'm going to say that as long as everything's qualified by physics, by practical reference, and it's no opinions, it's no beliefs, and it's proper science, that being, physicality, physics, demonstration, isolating variables and changing and altering them, then fine, I'm willing to step up for that. But I'm not going to enter into a discussion where it's purely rhetoric and these people don't have anything to qualify their position. I don't want to waste my time and my energy on, hot air.
No, I think that if you did do debates, though, and it's a timed thing, then it's going to show if you're able to bury their arguments or bury their position. So
yeah, that's fine. If people need the debate platform, that's fine. I mean, all these tests can be witnessed on my channel, Williams and Andrew's channel, that there's been a plethora of
So I would say that the main problem I've seen is the people who have come to me, there's 5 or 6 people who have come to me and they can't explain it at all, right? Yeah. They completely are just basically saying, I think Dell's right. And I say, okay, explain to me why. And they say, I don't know. I think that he has a point. And they can't explain it. If I would do anything, if I were you, I would try and work on helping them be able to better convey what you're trying to say.
That is the problem, Jeran, and not everybody's gifted with the ability
I know that.
Communicate.
But I'm just saying that if you, maybe it takes and you already have this. I don't watch your channel very often, so I don't know. But if you have like a nice, comprehensive, like maybe 20-minute summary, where it can be better, because you have to realize. So when flat earthers hear the Earth is moving upwards, they pretty much tune out, right?
Yeah.
So we're gonna have to get something to grab them.
Yeah.
This one here with the box and the helium, that's the one I've drawn out here on my iPad here, because I want to look at that. That kind of grabbed me, so that might be a good place to start.
Yeah.
Because you're right, there's something wrong there. I can't really work in my head. I was. Yeah. So anyway,
it's funny that you mentioned that, because for me that's the propaganda that was done to flat earthers. As soon as flat earthers arrived on this scene, that's immediately the first thing they were met with. The Flat Earth Society are controlled opposition, and the reason that's given for that is because they say the Earth moves upwards. Now, I asked that question, and I would ask you the question: where's the Flat Earth Society's presence been through this whole decade? It's not been anywhere.
Really gone.
Yeah, it's not been anywhere.
And they took that down, I heard?
Yes, they did. They removed it. Yeah.
Yes, I heard. Which
So,
I did think that was the first
Yep.
thing that made me go, that's weird.
yeah, because and now on the Flat Earth Society page they claim it's stationary.
And
So
they didn't used to, huh?
no, but obviously since I started bringing it forward, funny that they've removed that now. But as I say, I would ask people that question. Don't let the propaganda affect you. Ask yourself the intellectually honest
Let me
question.
ask you this intellectually. Do you believe in a creator?
Of course.
So do you believe the Bible?
No, I'm not religious in any way, shape, or form.
So would it be important for us to know that we're moving upwards? I mean, what would be the so if God didn't tell everybody that, does it really matter?
It matters in regards to the topic of the Earth's shape, because if you establish that the Earth's moving linearly, then that's an absolutely impossibility for a globe Earth to exist. It's over. The globe Earth, that's why I asked that at the very beginning. The globe Earth cannot even get off the drawing board without a physical downwards acceleration. It's impossible.
Right. And I've always, that's why I think that they have to hold on to gravity, even if it doesn't match observations, because
Yes.
there's no other explanation for the downward or the pull to the center.
They need it to explain antipodal people standing on a globe Earth and water all sticking to it and yada yada.
Right.
It's a requirement. Without that, it's absolutely impossible for linear motion to be happening on a globe Earth. It would tear itself apart in a very short space of time. It'd be over.
Yeah.
So it's the equivalence. That's all that they've done. They've taken natural phenomena and they've interpreted the natural phenomena in order to fit the model, which is, downwards acceleration. And if you look at all other examples, all it is visible interpretation. They have no physics, nothing.
Yeah, I know that.
No.
All right, well, we'll talk again.
No worries. Cool.
Later, guys.
All right. Good night.
Peace.
All right. Later, Jeran. Yep.